Okay, so we'll start and then I'll share my screen first. Okay, so hopefully you're able to see my screen. So please let me know if you are able to see my screen completely.
Sir, but the write-up is hazy. It's hazy.
Okay, let me see what is the problem.
Need to do focusing properly.
Oh, I think it was okay yesterday. Just the sharing, entire screen. So is it good now? Are you able to see the entire screen or not yet? Okay, wait. Now you should be able to see it. How about now? Is that okay? Are you able to see it, sir?
Now it's good, sir.
Okay. 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 So today, after a great talk by Dr. Jain, we learned a lot about the climate change and their impacts from an Indian context. So I will try to talk about climate variability, a little less about climate change, but then, of course, I will give you some of my research in different parts of the world. I did some research in Japan, US, and then India also. So I'll present some results about climate change and climate variability. Some of the methods are difficult to explain within the time, the amount of time we have, but I just point to the methods. You can always refer to my papers, but I'll try to do the best within 1 hour, 15 minutes if I can explain everything. Okay, so let's start. So basically, when you talk about climate variability, the climate variability is often manifested in the form of natural cycles. And these natural cycles are identified based on what we call teleconnections, in the sense that the variations in hydroclimatic variables happening at distant locations. When there is a pattern evolves, we call it as an oscillation. Now, we call it as coupled oceanic and atmospheric oscillations because many of these oscillations are driven by the interactions between atmosphere and the ocean. So therefore, we call it as coupled oceanic and atmospheric oscillations, or sometimes some researchers refer them as teleconnections or oscillations. Now, there are different types of oscillations in a sense that some of them are very periodic. They happen at a specific time intervals in terms of their phases of lengths. Some of them are irregular. For example, ENSO, the El Nino Southern Oscillation, is a quasi-periodic oscillation because it happens every 2 to 7 years, sometimes in 2 years, sometimes in 7 years. So in the sense that the phase change for these oscillations will be non-periodic for some oscillations. And there are decadal oscillations. There are multi-decadal oscillations, which have been identified by scientists. Now, these oscillations, these are not 21st century phenomena or so on, or 20th century phenomena. They are part of the longer time periods which they could identify based on paleoclimatology or hydroclimatology research, and based on tree rings, based on different types of measurements they could get, and they could confirm that these things are happening for millions of years. So that is the natural climate variability. So these oscillations may have impact both regional climate as well as continental scale climates sometimes. And some of the essential climatic variables we are interested as hydrologists or water resources professionals, we are interested in precipitation, temperature, and stream flow. In order to assess these changes, probably we need to come up with methods or a variation of the methods, both parametric and non-parametric methods, to see if the changes are statistically significant. So here's an example of the climate change and climate variability. Climate variability is that particular variations. We might still have a trend. That trend can be a part of the climate change signal. So as the climate change continues, on top of that, you still have the natural cycles which are going up and down based on the phenomena what we are observing. Now, has the climate variability intensified because of anthropogenic effects? That is very difficult to prove, as it is difficult to prove that anthropogenic effects have affected climate change in some parts of the world. Sometimes it is difficult to prove. But most of the time, according to AR6, Dr. Jain pointed out, we discussed yesterday, mainly there is no doubt that anthropogenic influences have impacted our climate. So as you can see, if you were to define them as probability distributions, for example, the temperature or precipitation, and you can see that there can be an increase in the mean or increase in the variance, depending upon that whether we get hot or cold weather or more hotter weather and so on. These things will happen. So a good definition for teleconnection is that a pattern or a mode of variability that can last for varying periods of time. Okay, there are long-term and short-term teleconnections. Tele means distant, and connections we know. So that's the whole idea of having this distant connections between two hydroclimatic variables varying in a particular pattern, and that pattern can have effect on regional climate. So here are some basic definitions. So climate variability is mostly due to natural internal process, whereas climate change can be a natural process plus the anthropogenic changes. So for example, climate change can be affected by a number of natural processes like volcanic eruptions and changes in sun cycles and so on. But then we also have the anthropogenic effects, which are changes in land use, the way we use the greenhouse gases, and so on. So obviously, because we are trying to understand the processes, we have patterns and teleconnections, and then we need to understand that there are patterns and there are processes which are influencing these patterns. And of course, in order for us to understand the regional changes, we need to understand what are these teleconnections. There are a number of teleconnections throughout the world, and sometimes you may have two teleconnections affecting at the same time. For example, the Indian context, India is affected by El Nino southern oscillation plus the Indian Oceanic dipole. So there are two oscillations which will have effect on the amount of rain India gets, the temperature changes, and so on. So sometimes you can have multiple oscillations, both may not be at the same frequency, but affecting the climate. And these we call the multiple coupled oceanic oscillations. Now, definitely it's difficult to study multiple oscillations at the same time because it's very difficult to decipher which one is causing what. Okay, so here are some of the well-known oscillations which affect different parts of the world. For example, Japan gets affected by ENSO and Pacific Decadal Oscillation. As you can see, decadal, so that means approximately every 10 years the phase of the oscillation changes. Then you have India affected by ENSO and Indian Ocean Dipole. Then US, the United States, is affected by 4 oscillations, AMO on the eastern side, ENSO generally in some parts of US, PDO on the Pacific side, and North Atlantic on the northeast side of the United States. So just look at one of the oscillations which affects the climate in the eastern part of the United States. We call it as Atlantic multi-decadal oscillation, and you will have both cool and warm phases. So this is based on the sea surface temperature measured, the average sea surface temperature measured in that swath of that region. And once we have that data, we can actually calculate the long-term average, and then we subtract the long-term average to see what are the warm and cool phases. For example, right now we are in the warm phase, so there are some different phases before. And this one seemed to have a lot of effect on different eastern parts of the United States, especially the state of Florida, where I live in. El Nino Southern Oscillation, you are very familiar with, and this is changes in the sea surface temperature in the central and eastern equatorial Pacific, and this can last anywhere from 6 months to 2 years. For example, we use a standard called Nino 3.4 region. There are multiple regions where you can measure the changes in the sea surface temperatures. So that is the span of the region where we measure the sea surface temperatures. Of course, Nino 3.4 is a special region defined by United States, but we do have other regions, slightly different. They're all in the same area, but the length of the region changes a little bit. But other than that, they are basically the same area where we measure the sea surface variations. So how does these oscillations affect our precipitation and temperature patterns? For example, if you're in El Nino December to February, you can see that India will be warm. Some parts of Florida will be wet and cool. So if you are in El Nino, we'll get more rain during our dry season. Our dry season is December to February. So you'll have a warm climate. Similarly, if it is El Nino June to August, you will be completely dry. You may not have a lot of rainfall. And we also face a similarity. So we don't have a lot of rain, or at least neutral, but the same style what we have in India. La Nina, from December to February, we will have a dry winter, basically. Right now we are in La Nina phase. And La Nina June to August, if we are lucky, we are right now in La Nina, and that will bring a lot of rain for your monsoon rainfall requirements. The Tropical Institute in India has projected that we might have a close to above normal monsoon season thanks to La Nina. But the problem is the IOD is having a little bit of a dampening effect. So it might affect a little bit, lowering the amount of rainfall you might get. Right now they are projecting up to 103% to 106% of the average rainfall that you might expect during the years, or summer precipitation or monsoonal precipitation. So this is the Oceanic Nino Index, and you can see that highly positive values indicate El Nino events, and we can classify them. For example, 2015 was a strong El Nino season, which dumped a tremendous amount of rainfall in California, in Los Angeles area. And we typically measure the 3-month averages. Anytime if it falls below 0.5, we try to see it as a negative 0.5 becomes La Nina, and anything above 0.5, the running mean for 3 months will be considered as El Nino. So right now, if you see, it is all blue. That indicates that we are in the process of excepting few months that was close to neutral, but most of the time we are in La Nina right now, because this is what it is indicating. So that is a good news for India, and not a good news for Florida, because we might get more hurricanes or cyclones because of the warmer sea surface temperatures, as well as the climatic conditions which favor the hurricanes. So this is the dipole mode index. This is typically used for your IOD. It is clearly linked with that. So you can see that we are in a negative IOD, and that's basically measured between these two areas, the sea surface temperature differences. And you can see that being negative has a little bit of dampening effect on the La Nina, which brings a lot of rainfall for India. So that is something we need to look into. The other one is the temporal windows. Typically, we can classify the El Nino into cool years, El Nino into warm years, and La Nina into cool years. So El Nino means a little boy. La Nina means a little girl in Spanish. So how this name's gotten, because the South American fishermen, they used to notice above average warm temperatures during the Christmas time, and they understood that this has to do with something with the baby Jesus, and then they called the phenomena at that time as El Nino, a small boy influencing this whole climatic pattern. Of course, they had to do something to give an opposite name. So they said La Nina, little girl, even though it's not a perfect word for that, but they just said, okay, it's opposite, so we'll just put it as a La Nina. Then the PDO phases, that is Pacific Decadal Oscillation, you can see the decadal oscillation going on there. 1900 to 1925 was classified as cool, warm, and so on. So you can see the phases where you have different years. Sometimes the combination of the influences will happen. For example, a combination of ENSO and PDO can happen, or ENSO and AMO can happen. So you can see that how in some time intervals, both of them are influencing your climatic patterns. Okay. So how do we assess these things? So the first thing is that you collect all the data, the hydroclimatological data, you identify the temporal windows. Most of the time, these temporal windows coincide with the phases of your oscillations. Develop indices. If you already have indices, you can use that. Use statistical methods to see if there's any significant changes in the variable values, and then you document that. Okay, so that's what it is. And then, of course, you have to look into all types of changes. We can look into general characteristics of the variables, trends and variations, interannual and intra-annual changes of extremes over time, changes in temporal occurrences of these extremes, and all kinds of things what we can think about, especially when we are looking at climate variability. Some of the recommended indices or parameters for climate variability studies are some of them you already know: coefficient of skew, kurtosis, Hurst coefficient, trend in mean, and so on. This is basically what they are doing is they're trying to calculate these values in different temporal windows and start comparing them to see if things have changed. So for example, if you're interested in precipitation, obviously you will be looking at seasonality, the persistence, transition states, inter-event temporal distribution of precipitation or intra-event, that is within the storm events. Temporal occurrences, are they occurring at different time intervals? IETD, I'm going to define that, and any other mechanisms by which you can understand the characteristics of the precipitation. You can look at seasonality by season SI index, or transition states can be evaluated by transition probability, persistence can be evaluated, nature of extremes can be evaluated, whether storm, convective or frontal systems, and so on. So the continuity of the rainfall events, we call it as the inter-event time definition. So the delta T helps us to define whether two rainfall events can be clubbed into one rainfall event or they are two separate rainfall events. So that's what we call it as IETD, the minimum temporal spacing at which two rainfalls are said to be belonging to two different events. So we can actually use that information to find out whether there is a difference between two rainfall pulses. So for example, here, the inter-event time is less than a specific threshold. So that means this whole thing is combined as a one rainfall event. The other one is another rainfall event. And there's a gap between these two are much longer than the T. So therefore, they are considered as separate events. And sometimes if the event is less than 2T here, the 2 times the threshold value, then the whole thing becomes one event. Okay, so basically what we could do is we can look at the duration, that is the length of the storm event, based on our definition of IETD. We can look at the gap between two events, and then the depth also, the amount of rainfall that happened based on our definition of IETD. Then there are 11 indices provided by WMO, which are very common, and you can develop your own indices, 1 day, 5 day maximums, simple daily intensity index, 10 mm, 20 mm, greater than 20 mm. You count the number of days. You count the number of days based on a threshold. This threshold can be fixed based on your Indian context or American context or any context. And then you also measure the consecutive dry days, consecutive wet days, that might give some idea about the droughts. And then also the 95 percentile, 99 percentile, and precipitation totals. So these are the ways we can calculate them. Some of them are actually just intensities. Some of them are counts. You count the number of days where the precipitation is more than 10 millimeters, more than 20 millimeters. and more than a specific threshold. In that case, these become basically like accounts. CDD is also a count, the number of days in which the precipitation is less than 1 millimeter. And if it is more than 1 millimeter, we will call that as consecutive wet days. And then, of course, R95 total, R99 total, percentiles, basically. And you can use any specific base period if you are working on. So, for example, right now, the base period is from 1991 to 2020. We call it as climate normal, the 30 years. So you can use that information to calculate your values. These are taken from the book, so you can see the chapter number and the equation number, one of my books. Okay, now the seasonality tells us whether the rainfall is happening only in a specific month or it is spread out in multiple months. So it's a very simple intuitive index. You can calculate seasonality based on the data you have, the monthly rainfall. That also helps us to understand what is going on with the seasonality in a region. So based on the index, you can indicate whether the precipitation is happening throughout the year and so on. So in Indian context, most of the precipitation is happening in the monsoon months. So our will be, the index will be close to 1.2 or 1.19 and so on. Then you can also calculate what we call the drought occurrence based on the monthly rainfalls. You try to fit a distribution to the monthly totals, 1 month, 3 months, 6 months, 12-month totals. And then you use a standard distribution to transfer that from the probabilities you get from the gamma distribution to a standard normal, so that you can indicate the index in terms of a normal variate. That means between -4 to 5 or whatever, and then based on that, we can define whether we have a drought or a wet year or some wet index. So in this case, the gamma distribution fits the 3-month totals. This is a site in Japan, so you can see that it fits very well. And sometimes when we are fitting the distributions, we need to estimate the parameters. The most common one is the maximum likelihood estimate, or you could use, yesterday we discussed the L moment and so on. The standard precipitation index we just talked about, based on the SPI values, you can say wet, extremely wet, and moderately wet, near normal, moderately dry, extremely dry, and severely dry. So depending upon that, we can classify. There are also indices for temperature, frost days, depending upon the temperatures you have, summer days, icing days, growing season length, maximum daily temperature, and so on. All this minimum, maximum, and so on, maximum of minimum, minimum of maximum, and so on. And the cold nights defined by a temperature, cold day times, warm nights, warm spell index, and all these things. So these are all given by WMO. Anybody who is interested in evaluating temperature indices, changes because of climate variability, we can look at. So a lot of changes are happening in stream flows also. And this is what we talk about, the least anthrogenetically distributed sites in United States. We have these sites which are available where there is no possible human influence. So we use that to get our information so that we can see any climate variability signal is available. So the questions we can ask is, what are the patterns in the annual peak floods? What's the variability of the timing of the annual peak floods? Changes in the number of largest floods above a specific threshold? Unexpected number of new peaks? And the other questions you can always ask about stream flow. Similarly, you can also ask for the low flow changes, whether there is a pattern in 1 day, 7 day, 14 day, and 28 day low flows, any record number of low flows we are seeing, any changes in the distribution of the seasonal discharge, and so on. So again, we can come up with our own indices to come up to discuss about changes. And of course, we do the flow duration curves. We look at the indices like 7Q10, the average flow values for a week calculated for a 10-year period, and so on. We can do that and calculate our indices. For environmental changes, again, we can look at the pollutant constituents, for example, dissolved oxygen or other ones which are measured for a longer period of time. You can look at event mean concentrations if there's any event. We can look at seasonal trends and so on. So the long-term changes, you can do both the joint assessments we did yesterday. We can do trends, we can do spatial and temporal variability, so that can help us in understanding the changes. Now, the sea level rise is also very important, and we have seen that trends are changing for most of the stations. We have around 374 sites throughout the world, and almost 70% of the sites are experiencing increasing trends, including India also. I'll show you that. And then some of the sea level rise issues are associated with the variability, that is climate variability also. So what kind of statistical tests we do? We do both parametric and non-parametric. In case of parametric, of course, we have to satisfy the assumptions of normality. In case of non-parametric tests, we don't have to worry about assumptions about normality. So we can do some tests for randomness, changes in the values, multi-sample tests, or two-sample tests. Again, there are a number of tests which we can apply. Then we can also look at the correlation measures that help us to understand the trends. For example, we can do a Spearman's row test for trends. Kendall's, that is Mann Kendall's tau can be used, or Mann Kendall test can be used for trend analysis, depending upon that. Or we can just use the Pearson correlation, which is a parametric portion. We can also compare kernel densities, so that it's much easier to compare when we overlap histograms on top of each other. And the kernel density is defined by a kernel, so you need to come up with a specific kernel to use. Typically, Gaussian kernels are used, and the bandwidth, which is the one which helps us to define the smoothing factor, as well as how much you can smooth on top of the histograms, that is optimized by softwares. For example, MATLAB automatically provides the optimum bandwidth. Trend analysis, as I said, we can do Spearman's row test or Mann Kendall test. Spearman's row test is a non-parametric. It doesn't have any assumptions. It is useful for monotonic trends. It doesn't have to be linear. And you can look at the test based on the t distribution, and you can actually calculate the statistic and say that whether the slope is statistically, or the correlation between the two quantities, the time and the variable, is different from 0 or not. If it is 0, that means there's no trend. Mann Kendall test can also be applied, but of course we have to be very careful when you are applying Mann Kendall test, because there are variants in Mann Kendall test depending upon whether the time series has autocorrelation or not, seasonality or not. So there are variants. You have to be careful to apply the right kind of Mann Kendall test. Linear regression can be applied, but again, linear regression is a parametric trend analysis. That means we are looking for actually some assumptions about the data, and then also the parameter theta, that is the slope of the line, has to be carefully evaluated using a t-test. So this becomes a parametric test. Once you have the linear regression line, you have to identify all those residuals. You check for the normality, the ones which we did yesterday. So again, this is a lot of work after you finish your trend analysis, because this changes to check the residuals for us. And of course, you can do a number of tests for the residuals. You can do Durbin-Watson test for the autocorrelations. You can check for visually whether there's any residual autocorrelation or not. Then, when we are checking the similarity of the distributions, we can do a goodness of fit test, like Kolmogorov-Smirnov test, two-sample Kolmogorov-Smirnov test, which we have seen yesterday. So let's look at quickly some of the case studies, the climate variability and climate change in India. So for example, this is a picture which gives you what is happening with respect to ENSO. So you can see that La Nina is the one which is bringing statistically significant higher amount of precipitation compared to El Nino, which is already well understood. I did this research because I wanted to understand how the monsoon is progressing and which areas are statistically significant in terms of La Nina affecting our rainfall pattern in India. So you can see that from June to September, most of the western side and middle central portion of the India is affected by the La Nina. And of course, you can see the progression. This is done by a gridded data set from IMD. Each pixel has been evaluated. We took the values, and then I evaluated the statistically significant differences. This is based on regions. We take the the monthly precipitation which is available for those regions, and you can see that statistically significant changes based on El Nino and La Nina, how it is affecting as it is progressing. from March to November. Interestingly, some parts of the India in the upper region, this is of course monthly values, are affected by El Nino. So they bring more rainfall in March and April because of El Nino as opposed to La Nina. So these are the homogeneous regions, and you can see which regions are affected, what are the properties for each of them, and that really helps us to understand how the progression of the the La Nina, El Nino influences is happening in India. Again, you can look at the indices. This is based on gridded data set, precipitation, totals, consecutive dry days, SDII, the intensity, R10, R20. And I can see that most of the time you have the strong influence of, these are trends, of course. So some of them are decreasing, some of them are increasing, some of them are, you don't see any change but the important thing is that the RX one day, the maximum rainfall is increasing in some parts of India, R10 and R20. So you have to see where this is happening. There's also the dry days are also increasing in some parts of India. The wet and dry spells, and you can see that we are talking about the number of wet spells, number of wet spell, the median values, then the maximum length of the wet spells. So you see a strong influence of La Nina in most of the cases in terms of the wet spells. But it's interesting to see that from the transition, so from zero rain to positive rain, La Nina is having a stronger effect compared to El Nino when it is going from a rain situation to no rain situation. The temporal occurrences of extremes, you can see that in case of El Nino, the extremes are occurring in June and August, okay? But for La Nina, they're occurring all over the 3 months or 4 month monsoonal period, okay? Now, is the temperature trends here based on 30 degrees, 35 degrees, and 40 degrees. So definitely, we are seeing an increasing trend in the temperatures which are more than 30 degrees, 35 degrees to a lesser extent. 40 degrees, some parts are experiencing an increasing trend. This is based on historical data, of course, 1951 to 2013. The other one is that the increase in the temperature max, Tmax. So you can see that this has effect on different crop productions, including rice, for example. A study says that an increase of 1.8 degrees will have a larger effect on your rice production. So let's look at the United States quickly. So this is done again with the gridded data sets. We compared each of them. Initially, I'm showing the correlations between different indices, AMO, PDO, NAO, and ENSO. ENSO has a stronger correlation for Florida. You can see at the bottom. AMO has some correlation, but you can see positive correlations in some parts of Florida. That is interesting. RX one day, all over the place. It's not giving a clear sign. Precipitation totals are interesting to note. For example, AMO has some parts of Florida receiving higher rainfall compared to cool phase, and red is a warm phase. Here, red is the El Nino, and blue is the La Nina. So entire Florida is affected by El Nino. And we also have the tropical storms, which bring in a lot of rainfall, including hurricanes. These are the pathways by which all the hurricanes hit the country. And you can see most of them hit around the eastern border. And you can see that a lot of them pass through our area. Of course, some of them are damaging, some of them are not. These are the pathways over different months. And you can see that most of them pass through Florida in this area in September. The rest of them will fizzle out and then go out of the Florida sometime in October. So our hurricane season starts in June, ends in November 1st. So what do we see? We see that there are more number of hurricanes making landfall, especially in warm phase compared to cool phase. And the opposite happens in PDO compared to AMO. And NAO, again, there are more storms in warm phase. We also see changes in the temporal occurrences of extremes. So for example, in warm phase, we see a bimodal distribution. That means they are happening in 2 months, the extremes, whereas in case of cool phase, they are happening all over the place. So that also helps us to understand when the extremes are occurring. This is an interesting graph, especially if you see this one at the bottom. So there's a nice cutoff of the precipitation. That means this part of Florida is influenced by warm phase, and this part is influenced by cool phase. So it is very difficult to explain why this demarcation is taking place. Of course, one way of understanding is that this is part of the continental Florida and this is the peninsular Florida, but that's not giving a lot of explanation. Then we dug into the different parameters. We found out that the soil moisture regimes are affecting the precipitation patterns, and you can see a clear demarcation in that, where you have exactly that line which is influencing the climate variability. And we also studied recently the associations between temperature and precipitation and with climate variability. They have been published in the last 2 years, and they indicate that climate variability influences are stronger than the local influences in producing those associations between temperature and precipitation. So sometimes what happens is that when you are dealing with two climate variability data sets, one climate variability phase is longer, like warm phase, and cool phase is shorter. So that means you have two different set of sample sizes. So then bias will come into picture. Then we devised a new type of sampling approach where we can sample repetitively from both of the available data sets. We call it as bootstrap sampling, so that we can bring the sample length closer to each other, then make comparisons. We can compare their confidence intervals and so on, so that we make that. So this is for the bootstrap sampling interval, or just for drawing the sampling distribution, we can understand that. So those are two things. You can look at the paper in Journal of Hydrology. So when we do that, we can see the effect as we see how the precipitation changes are happening for different hours. For example, we start from 1 hour to 120 hours because it is very important. We check for 5-day rainfalls, because in Florida we have these hurricanes coming, and they will affect precipitation patterns. So what do we learn from here? You will see that warm phase is, in general, initially both of them are similar, but as the duration progresses, warm phase is bringing more rainfall compared to cool phase, even at different durations. And we can also plot the probability non-exceedance plots, that is cumulative distribution function plots, and check what is going on in different regions. And different regions have different influences in terms of how warm phase and cool phase is affected. Here's another example of how statistically significant differences are happening because of the increase and decrease with respect to a two-sample t-test. Okay, so yesterday I talked about this. So the depth duration frequency curves, or the intensity duration frequency curves, are changing based on the data sets we are using. If you were to use only just the warm phase, you are getting a higher precipitation compared to if you use the entire data set. So again, that questions whether we have to use only a specific part of the data set for our design purposes. The kernel density estimates are nothing but smoothened histograms, so that we can evaluate what's going on with respect to different types of data sets. So one thing we need to make sure is that these kernel density estimates smoothly follow the distribution correctly. So we have to overlay on top of them to see if we are able to represent that correctly. Now, what we have seen when we did that whole analysis, we are seeing that as the time increases, there is a shift in the extreme precipitation occurrences when they are occurring. So slowly we started to see these bimodal occurrences for warm phase, and for cool phase you are seeing more extremes in the initial months, that is the dry season. So that means in the dry season we still have some flooding risk, because cool phase brings more extremes in the months of February to March and so on. The spatial variation is very evident. You can see that most of Florida receives more rainfall in warm phase compared to cool phase. We also looked at the antecedent moisture conditions. We actually looked at the previous 10-day rainfall values before the extremes. So when we look at that, we found out that the antecedent moisture conditions for cool and warm phases, as you can see, that the warm phase has a higher chance of wetter moisture conditions compared to cool phase. So this has implications on the floods, because if you're in a particular oscillation phase and then an extreme happens, you have more likely to have flood higher than if it is happening in the other phase. So you have to be attached a significance to the oscillatory mode. Now, the next one is the wet and dry cycles. These are the drought classifications. You can see that there are more droughts occurring in the cool phase compared to warm phase. And when we combine ENSO and AMO, that means we put on top of each other, both of them are acting in Florida. They are influencing the climate in Florida. So you can see that there is an impact that more droughts are occurring when you have La Nina as well as the AMO cool phase. So that's the problem we are noticing. So the sea level rise is an interesting issue for both Florida and many parts of the world. We have 374 sites we have analyzed. This work is already published. And you can see that most of the world is experiencing increasing trends. This was done by Spearman's row test as well as Mann Kendall test. They seem to match with each other. And you can see all the sites around India are experiencing increasing trends. And the eastern seaboard of United States and the western seaboard, some of the sites are indicating that we are having increasing trends in sea level. The sea level rise is also exacerbated by having the glacier melts. So there's a study which shows that even the floating ice, we think that as soon as a floating ice or a glacier joins the sea level will rise according to the weight of the mass of the glacier. But then they have proved that after it melts, it increases the height of the water. And so the idea is to understand what is the statistically significant changes. We also want to understand if there is any other issues with trend. We are also interested in what we call nuisance flooding. Nuisance flooding is basically whenever you have a increasing sea level rise, plus there is a high tide in some months of the year, the water comes inland and creates nuisance flooding. And this happens in Miami because we are on the coast. And sometimes the water, because of the high tide, as well as the problem with the increasing sea levels, water comes into the residential areas, it comes into the streets, and we call it as a nuisance flooding event. And this happens every year. And this causes interruptions to traffic, and people cannot walk. And this is not a damaging event where people die, but this is a problem. So what are the contributing factors? Thermal expansion, melting of glaciers, and we see that there is an increase in the sea level rise. Sometimes sea level rise will solve some problems also. For example, there was an island which India and Bangladesh were fighting for it, and then because of the sea level rise, the island got submerged, and we are no longer fighting. So this is very ironical that sometimes sea level rise will also solve problems for us. So we just saw that, and these are some trends for United States. You can see that increasing trends in all months. For example, if you were to classify based on the oscillations, AMO warm phase has higher sea level values compared to the cool phase. But ENSO, not much statistically significant on the eastern board, that is Florida side, but you have more clearer signal on the west coast. PDO, the Pacific Decadal, is just opposite. And the other thing is that if you were to plot the maximum sea levels in two different oscillation phases, you will see that there are higher possibilities of sea levels linked to La Nina compared to El Nino. So that means if you're in a La Nina phase, you are more likely experience nuisance flooding more than El Nino. So what are the things we are doing? We're trying to retreat from the coastal areas, move away from them, or we are accommodating, we are increasing the height of the houses, or we are constructing what we call sea walls. This is a protection from sea level rise. Of course, you will have coastal intrusion, saltwater intrusion also. Quickly for Japan, these are the 14 stations. These are the distributions of the data of sea level values. Statistically significant trends. So you can see that increasing trends for most of the Japan. And Japan is a very small country, and it has to be very careful about the coastal intrusion of salt water. And this is based on t-test. Of course, things will change because you're doing a parametric test. Then non-parametric test will tell you whether there are any changes with respect to El Nino and La Nina. This is again with the PDO. So which phase is influencing the higher sea levels. And this is a t-test again. Sometimes they match, sometimes they don't match. For temperature increases, I split the data into two 30-year intervals, and you can see that things are increasing as we progress into different months. So temperature increases are very important for Japan, for all agricultural production in Japan, very sensitive to the rice quality. They produce their own rice. And you can see that higher temperatures are happening in all the months. And you can see that the mean annual temperature is going up. And the temperature variations more than 30 degrees or 29 degrees are higher. That is also a little bit dangerous in many parts of Japan. More than 0 degrees, some parts of Japan will experience less than 0 degrees centigrade. So you can see, so the whole Japan is becoming warmer as we go into the 30 most recent years. So El Nino and La Nina, again, based on the temperature. So La Nina is bringing more extreme temperatures compared to El Nino. Extreme temperature occurrences have not changed. They are occurring exactly in the same month. But you can see the reversal for the December temperatures. El Nino is affecting more than La Nina. Again, you can see the temperature changes in December. But this September, there is a completely a difference happening, the reversal happening. Okay, so this is a very interplay of the El Nino and La Nina temperatures affecting. And this is again the September. So these are the influences of temperature for El Nino, and again for September and October and December. Suddenly El Nino takes over, but for September La Nina takes over. So you see that very important distinction happening. And the maximum temperature is again guided by La Nina. PDO influences, similar results, and these are some of the observations I have already talked. I'll continue. And then for precipitation, again, we have the same number of sites, 150 sites. We have increasing distribution of the number of gauges that are available as we go forward into the 20th century. So mean and variance, this is the variability in Japan. There's a strong lag one correlation, maximum and minimum, and the drought occurrences. Again, if you see precipitation, there's a reduction in precipitation in almost every month. So Japan is facing reduction in temperatures, increase in temperatures and reduction in the precipitation amounts. So that is not a good idea. The annual totals, not much changes. Seasonal totals, some of them are statistically significant, decreasing, but some of them are increasing. But most of the time, decreasing is a main issue because there's a water transfer that needs to be done between different provinces. So here's a spatial variation of two different time segments, the temporal windows, drier. And the temporal occurrences of extremes, you can see that for the most recent part of the century, you have flatter. That means that extremes are occurring in 4 months, whereas in the past 1940 to 1975, that data set indicates only extremes are happening in the month of July or mid-July. And we see that similar changes in the mean annual precipitation. Not much variation, but some parts are becoming wetter and some parts are becoming drier. El Nino, La Nina influences, we have already seen them, but I'm just showing spatially very quickly. And then December, we know that how El Nino is influencing the temperatures. Annual totals, not much. Sorry, that's for precipitation. And temporal occurrences of extremes, again, we see that for El Nino, it is 1 month, whereas this one is flat. There is a strong correlation with ENSO, which is expected because ENSO influences the precipitation and temperature of the Japan. And correlation, statistically significant correlations are only few in some parts. Seasonality, El Nino and La Nina, not much different, but in some sites, you see some small changes in the seasonality. As you can see from the cumulative distribution function plots, not much change. Seasonality index in some parts is changing based on the El Nino and La Nina. But the drought occurrences are changing between El Nino and La Nina. La Nina has less drought occurrences compared to El Nino. And you can see some parts are experiencing less droughts compared to El Nino. So you can see that El Nino is causing more droughts compared to La Nina in Japan. And that's shown by the antecedent precipitation conditions also, which we plotted 3 months and so on. The number of storms which crisscross Japan is also slightly different for La Nina and El Nino, extratropical storms. So PDF influences, again, the similar. And of course, I have not evaluated the combined influences of PDO and ENSO. The autocorrelation structure is also changing between PDO and cool phase and warm phase. So kind of observations which I've already indicated. Some parts of Japan having influences of both El Nino and La Nina, mild influences and strong influences. And PDO also has some influences on sea level, temperature, and precipitation. So finally, the implications are that rising sea levels, they are of concern both in Florida, maybe many parts of India and Indonesia and Asia, in many parts of Europe, because coastal flooding will start happening. Low-lying areas will be inundated. Storm surge flooding is very common in our places, and nuisance flooding is a big problem now. And there's also non-uniform variations in temperatures that will affect agricultural production in many parts of the world, especially in Japan and India and Florida and other places where agricultural economy is big. And of course, we may have water stress, increased urban flooding, which we are already seeing, extreme events and drainage issues. And every sector of the tourism will be affected, every sector from health to tourism will be affected by climate change and variability. So comprehensive studies have to be taken. We also understand the links between hydroclimatic variables and climate change. And also we need to understand the coupled oscillations. That's very important. We need to understand at finer time scales what is happening. And what are the implications for the infrastructure in different parts of the world? What are the adaptation measures we have to use? How to change our stormwater management operations? How to change our design? And as you can see, climate variability and climate change affects every part of the water cycle. And it affects the streams, rivers, power productions, and depending upon how much water that is available in your streams, both hotter and drier conditions and hotter, wetter conditions will have different implications in terms of how much extremes we receive. So what are the new research directions we can follow? Understand how multiple oscillations influence hydroclimatic variables. So for example, in the Indian context, you can look into ENSO and IOD how they play in trying to confine some of the rainfall patterns in different parts of the India, mapping spatial extent of these influences, and how regional hydroclimatology is restraining the spatial extent and temporal influences, evaluation of rare extremes. If you have some point data sets, you can look into that. Of course, precipitation estimation and analysis. And how do we change the operations, especially both climate change and climate variability, so that we can restore natural flows? And this is one of the big research areas in different parts of the world where they want to restore the flows to the natural conditions. And we can develop new extreme indices. So I think I went a little overboard, but I will stop there. And if you have any questions, I'll be happy to answer.
Sir, there are a few questions.
Yeah.
The first one is how to estimate the fluctuation and global teleconnection in the monsoonal floods associated with floods.
Yeah, in that case, you are looking at the annual extremes. I think floods it depends on the country. So if it is happening in India, most of your annual extremes are happening during your summer monsoonal season. The floods are happening. So in that case, you can always look into the temporal windows of ENSO as well as IOD and see how you can extract the data. And then the rest is more of statistical testing to see if there's any statistically significant changes between El Nino and La Nina, but I bet there will be, because the rainfall patterns are showing that statistically significant differences based on the historical data. So you will see that how monsoonal floods may be affected by different oscillations. And there are some studies in Australia where Australia is affected by PDO as well as ENSO, even to some extent IOD. So they have seen that the flood occurrences have changed because of the oscillation phases. So you can definitely carry out research in that direction as long as you have reasonable data to understand the stream flow characteristics. Some of the indices I have pointed out in the presentation can be used, not necessarily extreme peak flows, but also the characteristics of the stream flow changes. You can look into that. Okay.
The second question is related to this only, that how it can be said that changes occurring are due to La Nina or El Nina.
Well, well, there are two things that might be happening in any situation. One is the climate change that can be a long-term signal, and the other one is the climate variability signal. So in that case, if you are seeing some changes with respect to the temporal windows of El Nino and La Nina. Now, first of all, we know that El Nino and La Nina affects the rainfall patterns for India, and IOD to some extent. For example, IOD is now in the negative phase, so it has some effect on how it controls the La Nina. So La Nina is supposed to bring a lot of rainfall now because IOD is affecting that. So the only way to investigate whether there are changes because of these two types of oscillations, or you have to first split the data into different temporal windows and evaluate whether there are statistically significant changes in those variable values. If there are, not only just checking the statistical significance, we need to establish some kind of physical basis also, why that is happening, and why in one particular region, for example, if you take Western region, why that is happening, what are the other climatological factors that are causing. So you need to explain the physical basis to a certain extent, which is available through what we call atmospheric scientists, or any atmospheric science textbooks will tell us what are the effects of these oscillations on a physical basis, that is the geography, physiography of a particular region, landscape, and other regions of the world. So we can explain to some extent whether these things are not just a mathematical, arbitrary statistical significances, but they are definitely associated with a particular phenomenon. So that is how we have to prove that. So in that case, we need to show the physical basis.
Sir, again, one question is that data scale. Which data scale will give better results of climate change analysis or climate variability analysis? Daily, monthly, annual, or seasonal data? Okay,
so this is a what you call a region-specific question. So again, your objectives of your study. If you are interested in annual maxima, maybe you are only looking at the annual maxima. If you are looking at seasonal totals, you are looking at the seasonal totals. For example, you may be interested in the monsoonal rainfall effects based on El Nino and La Nina. So you only check for those summer months, June to October or June to November, to see how much is the monsoonal rainfall is changing with respect to El Nino and La Nina. For example, I showed the results that how La Nina within the Indian context is pushing that heavier rainfall compared to El Nino. Of course, that is gridded data. Now, if you are interested in small scale changes, for example, extreme rainfall events which are happening only in small durations, for example, 15-minute durations or 1-hour durations, then you might want to focus on rainfall extremes at that smaller time scale. Now, some of the indices are defined based on day. So if you have daily rainfall, then you can calculate all those indices which are provided by WMO, or you can devise your own indices. For example, if you are interested in droughts and all those things, they are typically calculated based on the monthly basis, the SPI index and so on. So seasonality is calculated based on monthly data. So depending upon your objective, you have to pick up a temporal resolution of your climate variable data. So that will help. But where the statistically significant changes occur, whether they occur at smaller time scales, whether they occur at larger time scales, we don't know unless we do the research. And these changes can be region specific. For example, if you're taking a state of Gujarat, then things may be different in that basin or in that state compared to what you are looking at South India. So again, the objectives have to be first laid out. You want to understand short duration rainfalls or long duration rainfalls or seasonal rainfalls or annual maxima, or you want to understand the variations in the indices. Then you try to collect the corresponding data sets and then try to do the statistical analysis. But nobody can say, there is nothing like better results. Results are results, whether you get statistically significant changes or no changes, or any changes in the characteristics of the variable you are looking at. So, but it all depends on your objectives. You need to define whether you are interested in, for example, if you're looking at urban areas in Mumbai, where you have all these extreme rainfall events affecting these urban stormwater management, where you have too much rain and too much runoff. In that case, you may be more interested in short duration rainfalls, because those create problems for the cities. And you have seen recently in India, Bangalore, Hyderabad, Chennai, these cities have experienced a tremendous amount of short duration rainfall. In 6 hours, you get a tremendous amount of rainfall. So that can be investigated. Sometimes you can also investigate whether these El Nino, La Nina effects, are they different in cities compared to rural areas? Because in cities, the heat island effect or other types of land use changes are affecting. So you might be interested in looking at whether ENSO has the same effect in cities compared to rural areas. So that can be another research direction you have. So you define your research direction and then look for the data, as opposed to looking for the data and then define your research direction. Okay, I hope I answered that question.
Yes, sir. There's one more question. In homogeneity test, what is the significance of new value?
Which homogeneity tests you are talking about? There are a number of homogeneity tests that are available, but at the end of the day, every homogeneity test will tell us that whether the data is homogeneous or not. So you can conclude that whether you need to work with the data, maybe you need to rectify the data if non-homogeneity is reported. Now, that is more critical for your climate change analysis. Okay, even for climate variability analysis, we don't want non-homogeneous data. So I'm not sure the mu which you are talking can be a method-specific parameter. So it depends on a specific homogeneity test. So, but in any case, you still, have to gather, as I told you yesterday, gather the metadata if possible. I mean, sometimes organizations don't maintain the metadata if they have changed an instrument or so on. So that is what I would say. Maybe we can discuss more in our tutorial session or some other time later about this. I think we have to think about the next session also. Any other quick questions?
Yeah, last question. Which climatic parameters have high temporal correlation on daily basis? Which climatic parameters have high temporal correlation on daily basis?
High temporal correlation on a daily basis. Again, it depends on what type of variable you are looking for. Temperature has correlation with what? With what other variable? I didn't understand. Climatic parameters have high temporal correlation. When you say temporal correlation, are you talking about autocorrelation or correlation with another variable? That's the
yes, sir. With same variable, autocorrelation.
Autocorrelation. Okay, so definitely temperature has always the strongest autocorrelation, because temperature, remember, temperature is a very smoothly varying parameter. You don't see a sudden shift in the temperature of 20 degrees. Suddenly it will not happen. So temperature over the time, even if you take monthly data, there's a very strong autocorrelation, sometimes weaker on a monthly scale, but daily, hourly, definitely temperature. The lowest correlation you would see at a daily level is for your precipitation, because precipitation happens in irregular pulses. So in that case, you don't see a strong autocorrelation for precipitation. So therefore, predicting precipitation using autoregressive models or time series models is more difficult than temperature. Okay.
Okay,
So
thank you,
somebody
sir.
said, yeah. So yeah, we will discuss about the homogeneity test, or I will. You can send me an email. I will answer that question. Okay.
Okay, sir.
Okay.
Thank you very much.
Yeah.
Rashmi, we need to take again photo or screenshot. Rashmi, are you there?
Yes, sir.
Take
Let me
attendance.
stop sharing the
Yeah, please.
screen. Okay.
Everyone, please turn on your camera. Rashmi, please take screenshot for attendance. So, sir, next session is mine, and I think we'll start at 6:20 p.m. So 15 minutes
So that
break, and
15
after
minutes
that
break.
we will start.
Okay. So please, 15 minutes break. Okay. Good. Okay. Perfect. So I will try to post all the materials tonight to the Dropbox, or I can directly send it tomorrow morning to all the users. Maybe I'll post it in the Dropbox so that it's easier for you to share with all the members. Right?
Okay, sir. And if you can access Google Classroom, you can upload in Google Classroom also, sir. Can you able to access Google Classroom?
I think I should be able to. So I'll post it there.
I
Okay.
tried to add you with your FAU ID, but the Google is not allowing.
Okay. I will double check today.
Okay. And one more thing,
Okay.
that tomorrow, sir, we have one session where I have invited all the Indian academic as well as field experts from 5 to 6:15 p.m.
5 to 6:15 p.m. Okay. Good. Do you have the I know you wanted to ask some points for us to discuss.
Yes. And
Right.
I got some points from 4 or 5 experts also. That also I will
Okay.
share with you tonight, so that you can
Okay.
see that in advance. At the
Then
same
I
time,
can add.
you also can participate. What are the challenges which are faced by India as far as the because of evolving climate? So you also keep your point ready. It will be a kind of discussion online, 1 hour 15 minutes, wherein the academic as well as the field experts are joining you.
Okay. That will be perfect.
Okay, sir. Thank you very much.
We'll meet in 15 minutes then. Okay.
So good evening, everyone. Hello. Either you turn, I think you all turn on your cameras. Please turn on your cameras for my lecture. Shudhanshu, Vipin, Darshan. Darshan is there. Pallavi. Surinder Natarajan.
Yes, sir.
Vipin has raised hand. Maybe some problem with camera.
Yeah, Surendra Natarajan is there, sir.
Bosco. Bosco. Jesse Kurba. The name what I see that I am pronouncing. I see Chella Pratyusha also. Is she here? Chella. Hello, is my screen visible?
Yes.
Okay. So, as we are discussing since last 2 days about spatial modeling, I have taken a case study that how spatial modeling be used for analysis purpose, or how the spatial modeling is done for flood risk assessment. The case study which I have selected of Girna River Basin. The Girna River is one of the major tributary of Tapi River. As you know, Tapi originates and flows towards the west side of the India, and near Surat, it meets the Arabian Sea. So Girna River is tributary of this Tapi River, one of the major tributary of the Tapi River. Also, this is a paper which is published in Natural Hazards Journal, which I have already shared with you in Google Classroom. So we know that flooding is the natural phenomenon which occurs across the globe. It affects largely on human societies and on agricultural areas. Flood can have major environmental and sustainable benefits. Whether slides are changing or not?
No, they're not changing for some reason.
Slides are not changing.
I don't know.
Okay, 1 minute. I'll check it again.
Maybe try to share the entire screen when you're
One
trying
minute.
to share the screen.
I'll do one thing. I hope my slides are visible and now it's changing also.
Yes, sir.
Yeah. Okay. Okay. Fine.
Yes, sir.
Okay. So floods can have major environmental and sustainable benefits concerning to the regions which suffered from prolonged drought. What is flood hazard? So flood hazard means the threat of an area being inundated by water, typically due to excessive precipitation or obstruction to the natural flow. While what is vulnerability? So vulnerability is a condition which is influenced by physical, social, economic, and environmental factors that raises the susceptibility of people to the hazard impact. While the flood risk is a combination of the probability of an event happening and the consequences if it occurred. The flood risk index mapping can help to indicate the level of risk of the area for the flood disaster. By mapping hazard zones, mitigation measures that decreases the impact of possible flood events like flood early warning systems and response strategies that are best suited for the affected area can be developed for future flooding events. What is risk? So you can see here hazard into vulnerability. That combines the risk. And what is risk? What is hazard? The potential threat to humans and their welfare. What is vulnerability? Exposure and susceptibility to loss. And what is risk? The probability of disaster occurrence. Hazard is a physical event that can potentially trigger a disaster. Vulnerability is the degree to which communities are susceptible to loss, damage, suffering, and death in the event of a disaster. Basically, depends on localized features that decide the degree of vulnerability, that is physical, social, and economical. Risk is the probability or likelihood of a disaster impact after taking vulnerability and hazard into consideration. Flood risk assessment. You can see the map here, wherein hazard map, which is inundation with which has been obtained through simulation. Vulnerability map, spatial distribution of vulnerable socio-economic and environmental conditions. And risk map, it is a combination of hazard and vulnerability map which enables the identification and ranking of endangered areas. Flood risk assessment and mapping using geospatial and AHP, that is MCDM approach. The study area, as I say, lies in the middle of Tapi River basin, extending from Hatnur Dam to Saukheda, Jalgaon in India. It has a catchment area of 14,927 kilometers square, and this river have 5 tributaries. The left-bank tributaries are Vagur and Gir, which covers most of the drainage areas, while 3 small right-bank tributaries are Sukhi, Mor, and Gul, encompasses a small drainage area. The Gir River tributary originates in the west from the Camp Peak located in the Nasik district and flows towards the east opposite to the Tapi River. The Gir River, which is the second largest tributary of the Tapi basin, does not have a gauge discharge measurement site. An unprecedented rainfall, which was recorded in the catchment area of the Wag River in 2006. The meteorological stations are sufficient in the basin, but the river gauge discharge are insufficient for the prediction and validation of the rainfall runoff process modeling under the present study area reach. This affects the decision-making activities for the stakeholders and policymakers. So this is the study area where you can see the left-hand side where it is written Kalwan. This is the site from which the Gir River originates. In the center where it is written Girna, there is a Girna Dam. This Gir River further flows towards the Tapi River, and you can see on the right hand side there is a Hatnur. This Hatnur and the Hatnur Dam is on the Tapi River, and the Girna joins the Tapi River near Saukheda. So this entire region is considered as study area, which have major stations, rain gauge stations, and river network, including the one major dam, Girna Dam. What is the scope of the study? To develop a spatial flood risk index map for the part of Middle Tapi subbasin using geospatial and AHP approach by applying remote sensing based composite flood hazard index and flood vulnerable index. That includes identification of key flood causative factors applicable to data scarce areas, derivation of spatial data for the flood causative factors from remote sensing, and application of a composite FRI to the study area. Methodology. To decide the weights, multi-criteria decision-making analysis, AHP, approach is used to understand the influence of each factor responsible for the flood. And for developing a spatial database, all factors those are considered in developing flood hazard and flood vulnerable index map for the study area in GIS platform has been made in this study. The flood causative factors, the identification and selection of the flood causative factors is a very crucial step in flood risk mapping. The selected factor should encompass the properties of the given watershed. The factors considered in the present case study are based on literature review, data availability, and basin characteristics. For developing spatial map of flood hazard index, slope, drainage density, distance from main river channel, land use land cover, soil, and rainfall has been considered. While developing flood vulnerable index map, crop production, population density, road river interactions, these three factors are considered. This is the flowchart of entire analysis, wherein first the spatial database has been made for flood hazard index, which is shown on the left hand side of the screen. Then flood vulnerability index, FVI, that is shown on the right hand side of the flowchart. This spatial data set which has been developed, that has been used.
Excuse me,
again, sir. Yeah.
Acha, flowchart was not visible. Just
yeah. I think you wait for a few minutes, and after that, I think the slides are changing. Okay. So spatial database. So that spatial database for flood hazard index and flood vulnerability index have been developed, and applying AHP, multi-criteria decision making, the flood risk index map has been developed in this specific case study. So one by one we will see that how the flood hazard index, flood vulnerability index, and then flood risk index maps were generated for this particular basin. So flood hazard index, creation of spatial data for flood hazard index map. We have considered the 6 parameters. What are they? Slope, distance from main river, land use land cover, soil type, drainage density, and rainfall. First, slope map. The steepness and length of topographic effects on discharge. Steep or high slope are responsible for high velocity of runoff generated after rainfall, while low or flat slopes are dense, quick flooding or waterlogging situation causing high infiltration. The NASA DEM of 12.5 meter resolution has been used for the creation of slope map. The DEM has been downloaded from Earth Data NASA website. The slope map is classified into 5 grade categories: 0 to 6 plain terrain, 7 to 22 mild, 23 to 45 medium, 46 to 81 high, and more than 82 very high or steep slope. From the slope map, it can be seen that along the boundary side and the originating place of the Girna, Vagur River and north part near Karbadi Dam, there is a steep slope, and the central part have almost mild to plain slope. So this slope map has been developed, wherein you can see that the slope percentage, which is given on the right hand side, but different color, 0 to 6, 7 to 22, 23 to 45, 46 to 81, and more than 81%. Second factor is distance from main river channel. The main river channel, along with their tributaries, is highly vulnerable to flood, as the water in the stream network overtops the nearby areas from both the banks are most affected by flood. As the distance from main drainage network goes on increasing, the susceptibility to flood inundation water goes on decreasing. The distance from the main river channel has been mapped using Euclidean distance tool from spatial analysis tool using ArcGIS 10.2. The distance interval used were categorized into 5 classes: 0 to 500 meter, 501 to 1000 meter, 1001 to 2000 meter, 2001 to 3000 meter, and more than 3000 meter. This is the distance from river map, which you can see here: 0 to 500, 501 to 1000, 1001 to 2000, 2001 to 3000, and more than that of the 3001. So this is the second factor for which this map is generated. Land use, land cover. The land use, land cover has influence on the hydrological processes like precipitation, interflow, base flow, evapotranspiration, infiltration. The agriculture area, water body, and barren land cover are largely affected by flood water due to higher runoff, while the forest and grassland results into less runoff. For this study, Landsat 8 image of 30-meter resolution for the year 2010 used for land use land cover classification. The satellite data covering the study area were obtained from USGS Earth Explorer site. These data sets were imported in ArcGIS 10.2. In the present study, for land use classification, supervised classification method is used. Maximum likelihood classification technique is applied to the land use and land cover classification. The study area is classified with 5 classes, namely water, built-up, agriculture, forest or dense vegetation, and barren land. After processing it in ArcGIS, the water, agriculture, urban, bare, and forest areas been marked. The map of LULC has been prepared for the study area. This has been followed by soil map. The soil type present in the study area plays a very crucial role to identify the flood susceptibility of any region. The water holding capacity and infiltration characteristics of the particular soil type have control on flood inundation depth. The runoff generation rate after rainfall is more in clay soil as compared to silty or sandy soils. The soil map and soil details for the study area were obtained from the National Bureau of Soil Survey (NBSS) and the Land Use Planning (LUP) Nagpur. The portion of the study area was extracted from the NBSS and LUP soil map to make shape files in ArcGIS. The classes of generated soil map are clayey, sandy, silty, loamy, and rocky respectively. So this is the map which is prepared, soil map which is prepared using ArcGIS. Drainage density. The drainage density is defined as the ratio of total length of stream of all orders within the basin to its area. Higher the drainage density indicate existence of mature one or more developed channel system, and lower the value, coarser is the drainage density, which shows low infiltration soil or impervious geology. The surface runoff moves more rapidly from the edge of the catchment. The drainage density is calculated using line density tool in ArcGIS. The input data set of river network and Landsat 8 satellite image of study area is used while preparing drainage density map. So this is the drainage density map where drainage density is in kilometer per kilometer square, what the varied values ranging from 0 to 0.015 to 1.523. Sixth parameter, that is rainfall, is the major factor which contributes more in flooding of the Tapi Basin. The average rainfall, the annual average rainfall of the study area in flood event of the year 2006 varies from 734 mm to 1458 mm. The rainfall data received from Indian Meteorological Department IMD has been used to make rainfall map of study area. So the rainfall of particular region plays very vital role in flood hazard risk map. The high intensity rainfall for long duration will generate more amount of runoff. The probability of flood increases as the magnitude of rainfall increases. The rainfall map were prepared using IWD, that is inverse distance weight method, for 15 IMD rain gauge station. This is the rainfall map of the study area for the year 2006, where the various classes of rainfall, right from 850 mm to 1458 mm, has been considered. Flood vulnerable index. Generation of spatial data for flood vulnerable index map. My slides are changing or not? Hello?
No, sir.
No, sir.
ये वाला चालू कर दो। I hope now it's changing fast. Hello? Is it fine now?
Yes, sir.
Okay. So what I was discussing about flood risk assessment and mapping using geospatial and AHP, that is MCDM technique. In that, as I have shown this methodology, that flood hazard index FHI, flood vulnerability index FVI, and flood risk index map that has been developed. In that, the first we have seen flood hazard index, and for hazard index generation of spatial data for 6 factors which I have considered here, that is slope, distance from main river channel, then land use land cover, soil type, drainage density, and rainfall. And for this, these 6 maps are prepared. That is first for slope map, then second distance from main river channel, this is second map. Land use land cover, this is the third map which is been prepared, land use land cover. Then soil map, then drainage density, rainfall, now for flood vulnerable index, again creation of spatial data. Here we have considered 3 parameters, that is road river intersection, crop production, and population density. So first, for road river intersection of road network, depending, the entire region is divided into subparts, which is called as taluka places. And for these taluka places, the intersection of road and river that has been identified as shown in the network with the red dots. While this road river intersection numbers has been identified, that is number of points per square kilometer per taluka. So per one particular subdivision, you can say taluka place, that is a kind of division made for identification of a area. The second one is crop production. Agriculture area plays an important role in the economy of that region. The present study area possesses maximum agriculture area. This is one of the key factors which is considered while computing economic loss of the particular region after flood disaster. The agriculture area having maximum crop yield will be more prone to flood vulnerability and vice versa. The annual average crop production data from 2004 to 2016 were downloaded from the official website of the government of Maharashtra. The average yield was calculated taluka wise for the study area. The data were plotted polygon wise using ArcGIS. The data set were converted into raster using polygon to raster tool. The average yield of the all crops present in the study area was summed to find total crop yield of that particular taluka in kg per hectare. And this is the map wherein you can see crop production kg per hectare with different values as low as 5,724 kg per hectare to as high as 30,830 kg per hectare. And the third parameter which we have considered is population density. The population is one of the vital social factors which are to be considered while doing flood vulnerability study. To assess social loss and flood damage assessment of the community, this factor plays very key role concerned to flood vulnerable areas. Population density of Jalgaon, Nasik and Aurangabad district has been mapped taluka wise as per the Census of India 2011. And the population density per person per square kilometer spatial map has been developed as shown in this particular slide. After two data sets, development of two spatial data set, one for flood hazard index, another flood vulnerability index. Now AHP is used to decide weights of the various factors which we have used for development of flood hazard index as well as that of the flood vulnerability index. The analytical hierarchy process, AHP, is the method well studied when policymakers have to take decision based on numerous criteria and availability of physical resources. AHP is the most recommended and most suited MCDM method that was developed by T. Satie. The Thomas Satie has developed the AHP based on three principles: decomposition, comparative judgment, and synthesis of priorities. AHP is a mathematical method of analyzing complex decision problem with multiple criteria. It involves construction of pairwise comparison of matrices at each decision level, and finally aggregating the different factors to calculate the relative importance of the factors and sub-factors over each other. The AHP methodology starts with the goal which comes at the top of the hierarchy, and that hierarchy further categorized in criteria, sub-criteria according to the study area. In the current research, AHP technique is used to understand the influence of each factor responsible for the flood. The rating scale set by Satie, which is varying from 1 to 9, that has been used in the present analysis. The smallest value represent least importance and largest value represent more influence. In the present AHP model, first step is to decide the effect of other compared factor in concern to the flood over one another. According to its importance, the weights are assigned. If required, the weights are assigned reversely depending upon its respective comparison of pair and weight decided for that comparison. The computations were performed by AHP extension in Excel. So scale of preferences between two parameters in AHP, that is defined by Satie. 1, the two activities contribute equally to the objective. 3, experience and judgment slightly favor one activity over another. 5, experience and judgment strongly favor one activity over another. 7, very strong, and activity is favored very strongly over another. And 9, that is extreme, the evidence favoring one activity over another is of the highest possible order of affirmation. While 2, 4, 6, 8 are the intermediate values to represent compromises between the preferences in weights 1, 3, 5, 7, and 9. Reciprocals of this, that is 1 upon 3, 1 upon 5, 1 upon 7, 1 upon 9, that signifies opposite, or for inverse comparison. The 1 upon 3, 1 upon 5, 1 upon 7, 1 upon 9, that can be used for the inverse comparison. The main goal of the present study is to make flood risk index map using AHP MCDM approach to decide the weights of selected factors. The next sub-level is to divide this goal into two decision factors, that is flood hazard map and flood vulnerable map. Further, next third level classification under flood hazard index are rainfall, slope, drainage density, land use land cover, and distance from main active channel and for flood vulnerability index, road river intersection points, population density, and crop production. Pairwise comparison of each parameter at third level using Statistical of decision matrix has been used. The calculation of principal eigenvalues to check consistency of weights has been carried out. The calculation normalization of eigenvectors is done by normalization process. This helps in removing biased approach during assessment of weights to the factors which affects on the consistency ratio. The obtained value of CR must be less than or equal to 0.1, that is 10%, to be considered. This reduces bias error in the process of weight assessment. The consistency index is given by equation 1, that is lambda max minus n upon n minus 1, where lambda max is the average number of consistency vector and n is the number of factors considered. While the CR, consistency ratio, is the ratio of consistency index over randomization index. This randomization index Ri, as shown in this table, for various matrix sizes defined or provided by SATI in 2008. For example, our matrix is of 6 by 6 size. The value of Ri is to be considered is 1.24, and considering that, the value of CR, that is consistency ratio, be computed. So, goal 1, what do we want to develop? Flood risk index map. Therefore, goal. So that is our level 0. While main criteria, level 1. So for level 1, we have two parameters: flood hazard index, flood vulnerable index. For flood hazard index, what are the parameters which we have considered for development of flood hazard index? That is given as sub criteria level 2, which includes slope, distance from main channel, land use land cover, soil, drainage density, and rainfall for the flood year 2006. Flood vulnerable index FIR, its sub criteria are road river intersection point, crop production, and population density. The level 3 for flood hazard index, slope in percentage. So that slope is, again, as you have seen in the map, we have classified into various categories. So 0 to 6% plain terrain, 7 to 22% mild slope, 23 to 45% medium slope, 46 to 81% high slope, and more than 82% steep slope. Similarly, the soil is classified into 1, 2, 3, 4, and 5. As we have developed the spatial map for soil, what were the classification? These were the 5 classification. Similarly, from distance from main canal. So there also the groups were made 0 to 500, 500 to 1000, and so on. Drainage density in kilometer per kilometer square. The values are shown over here. Rainfall, the rainfall classes are shown over here, and land use land cover, water, agriculture, barren land, built area, and forest. This is exactly same as that of spatial map which we have developed for flood hazard index parameters, giving the various sub classification of each. That is required at level 3. This is done for flood hazard index. Similarly, we will do it for flood vulnerable index. And in case of flood vulnerable index, road river intersection, number of points per square kilometer, that has been again further sub classified into 1, 2, 3, 4, and 5 groups. Crop production, again 1, 2, 3, 4, and 5 groups, and population density, that also classified into, further sub classified into 5 groups. Once you have all these groups, we need to prepare AHP questionnaire to decide weight. How this AHP questionnaire is to be prepared? So a survey form is to be made. In this, the details about the factors considered for flood hazard, factors considered for flood vulnerability, explanation of these factors to the expert that for which purpose you are developing the AHP questionnaire is required to be briefly written in the beginning of or at the top of your survey map. The instruction for filling up this questionnaire survey with, as we know, flood hazard have 6 parameters. So 6 into 6 square matrix. Flood vulnerability have 3 parameters. So 3 into 3 matrix. And how to fill it? That is 13579. And what does 1 mean, 3 mean, 5 mean, 7 mean, 9 mean? That you have to briefly explain in the beginning of the questionnaire survey before distributing it to the experts. So this is a format of a questionnaire survey wherein you can see the main factor. So main factors were 6 and these 6 factors are compared with the other 6 factors. So first you have to choose one factor like slope. So that slope you have to compare with 1, 2, 3, 4, 5 and 6 parameters. So slope is compared with slope. Then the second parameter, distance. So again, distance will be compared with again the 6 parameters. Similarly, land use, land cover, 6 parameters are compared with the 6 parameters. Here, meaning of comparison means when you compare slope with slope, obviously it will, the expert will mark 1. They are equally important. When we want slope with distance from main drainage network, slope with distance from main drainage network. So out of these two, which one is more significant? Someone feels that no, slope is more significant than the distance of a particular point from drainage network. The expert may tick mark 5 on this side. If slope and soil type are there, an expert feel that the soil type is more significant than that of the slope, then he may tick mark 5 on the right hand side. Then tick mark 5 on the right hand side. So similarly, all these 6 parameters are compared with the 6 parameters and weights has been given by experts when comparing these parameters with each other. So this is the main criteria. So main all 6 criteria are compared with the 6 criteria. This is the criteria for vulnerability, 3 criteria, and 3 criteria are compared with the 3 criteria. So such type of a questionnaire has been prepared and that has been distributed to SMC engineers, design engineers, academicians, experts working in the area of floods. So this you can see here. These are all Surat Municipal Corporation engineers, and we have asked them to fill this questionnaire survey form. This is another picture where they are filling the questionnaire survey. How the design of weights are carried out. The weights of selected criteria were taken from expert opinion. The expert were chosen from, as I have already told you, water resources engineer from SMC, irrigation division, basin planner, assistant engineer from CWC, consultant from water industry, researchers who work in flood analysis, and professors from IIT. Total 60 forms were surveyed, out of which, after checking bias approach for consistency ratio using AHP Excel sheet, 20 forms were rejected whose CR value is less than or greater than 10%. This is very important step. What happens in case of questionnaire survey? you get the form from the expert and you use that data directly for the analysis purpose. That is not correct. What you are required to do is you have to check for that individual form also whether this consistency ratio is less than 10% or not. If it is more than 10%, then that form filled by expert cannot be used for the further analysis purpose. So the questionnaire forms whose CR value is less than 10% were processed further. The final weights were decided based on geometric mean method for both flood hazard index matrix and flood vulnerability index matrix. Here, the final flood hazard matrix considering 30 survey forms, because the total 60 forms we have collected. Out of the 60 form, 20 were rejected. So we got 40 such tables. And out of these 40 such tables, using geometric mean method, the final weights are derived as shown in this particular table, wherein the CR ratio is 0.091. Assign rank of different classes of total 6 parameters which were considered while making flood hazard map. The spatial map which we have developed, slope in percentage, this classification is again rated. Suppose the plain terrain, the rating of that is 1, while the steep slope, the rating of which will be 5. And the weight derived using Ahp method is 0.06 for slope. How this weight is derived? On day 5, last session, I have designed one tutorial in which we'll be actually doing this exercise and trying to find it out, the weights for it. So for slope in percentage, 0.06, distance from main river channel 0.21, land use land cover 0.060, soil that is 0.08, drainage density that is 0.16, and rainfall in mm 0.43. Why the rating is given 1, 2, 3, 4, 5, that I will explain in the further slide. Similarly, using the 40 forms final flood vulnerable matrix 3 by 3 using geometric mean method has been derived, and these are the final rating given by experts for flood vulnerable matrix parameter which have consistency ratio 7%, which is less than that of the 10%. So 0.07, that means 7%. So assigning again based on the distance in kilometers, right from 2 to 32 kilometers, ratings 1, 2, 3, 4, and 5, and the weight derived for this parameter is 0.90. While for crop production, it is 0.72, and for population density, it has come out to be 0.08 with rating. The weights of selected criteria were taken from experts' opinion. And who were the experts? That already I have explained you. The questionnaire forms whose CR value is less than 10% were processed further. The final weights were decided based on the geometric mean method for both flood hazard index matrix and flood vulnerability index matrix 3 by 3. This is, I think, yeah. So we have completed first the spatial development, spatial maps for flood hazard index, FHI, then flood vulnerability index, FVI, We have gone for classification of slopes also, and for each slope we have given the rating also for all 6 parameters. Similarly, we have done it for flood vulnerability parameters. Then we have gone for deciding of weights, AHP weights, and now using these AHP weights, we wanted to define flood hazard index, flood vulnerability index map, and flood risk index map. So GIS integration for flood hazard index map, 6 parameters, namely rainfall in mm, slope in percentage, land use, land cover area in square kilometer, drainage density kilometer per kilometer square, distance from main river network in meter, and soil type in square kilometer are overlay with each other to generate flood hazard index map using weighted overlay linear combination after giving finer normalized weight in ArcGIS. The FHI is calculated as sigma I is equal to 1 to n Ri into Wi, where Ri is rating of the parameter in each point, Wi is the weight of each parameter, and n is number of criteria. So this value 0.06 that is derived using AHP, while slope of a particular region, entire basin is divided into different regions, different parts. So for one particular part, what is the slope value? Depending upon that, the rating is to be chosen. Here, if we take slope, suppose on a map, a particular area is having mild slope 7 to 22. So for that, the rating will be 2. And that will be multiplied by 0.06. For clear understanding, again, I will show you one map, then you will understand it clearly that what I am trying to work out. Let us say this. Okay, so you have, for example, Satna, and it's have 209 to 294, right? We have classified the population persons per square kilometer is 209 294. So when we will find it out, FVI, the rating for this may be 1, 2, 3, 4, and 5. Then for Satna, you have to multiply 2 into the weight of population density for category number 2. If you have population of Jalgaon, which is 512 to 833, there you have given rating 5. So when you want to work out FVI, because these are the parameters of FVI, so what you will do, 5 into weight of population density for this Jalgaon. So that way, for entire area, your rating somewhere here it will be 1, here it will be 2, that Satna will be 1, Kelvan will be 2, Malegaon may be 3, Chalisgaon may be 4, Chopra may be 5. So depending upon the population density, the rating will change. And this rating is multiplied by weight. So what we have done here, for FHI, this individual rating is multiplied with its weight, and that is aggregated. I is equal to 1 to n. So whatever sub-classification you have done, for all you have to consider it. That is I is equal to 1 to n, Ri into Wi. For slope, for the entire basin, that you have to multiply it by 0.06. Then second parameter, LULC, again as drainage density and rainfall. This will generate the flood hazard index map for entire region. This final map which you are preparing, that is also have various values, because your value of FHI will vary depending upon the classification of that particular parameter, and therefore for each section the value will be different. These values are again classified into 5 categories. The final map is divided into 5 classes depending upon the value of FHI. They are high risk, high, medium, low, and very low, respectively, based on geometric interval method. So, flood hazard index map has been developed using GIS integration following the computation of FHI for various areas using the equation of FHI is equal to sigma I is equal to 1 to n Ri into Wi. Ri into Wi. Okay. This one, Ri into Wi. When you do this, you have got this map, which is flood hazard index FHI. So that's what I was talking about, this Satna. So this Satna will have 5 parameters, 6 parameters. So all these 6 parameters that you compute and multiply it by its weight, then it will give you this particular variation. Similarly, for all other regions like Chalisgaon, Malegaon, and all other regions, the flood hazard index map has been prepared. The same procedure is followed, but before going for flood vulnerability index map, how the flood hazard index map is useful. So as we know, the flood hazard index, if you overlap on a Google map, what you can find? The classes, very high classes, which are the villages which comes under flood hazard index, high areas. Is it not changing? Okay. And the area covered in square kilometer, that is 527.62. Similarly, the villages which falls under high class, so that has been identified, and the area which is at high hazard, that has been computed. The moderate one, the areas in the study region, that has been identified. At the same time, the square kilometer of that has been computed. Similarly, for low and very low areas. Once the FHI is developed, now we want to go for flood vulnerable matrix. This matrix, after considering 40 forms whose consistency ratio is less than 10%, using geometric mean method, the final values for flood vulnerable matrix been decided. The consistency ratio for this is less than 0.0, that is less than 10%. Assign rank of different classes of total 6 parameters, which were considered while making 3 parameters, not 6, flood vulnerable map. In this again, as I said, the classes are made and rating are given. That the area is very close to river will be highly vulnerable to floods. So value of 5 is given here. While the area which is far away from the river is less vulnerable to flood, so value of 1 is given. Similarly, the crop production you will see here, that crop production yield kg per hectare for each taluka, the ratings are given accordingly. For population density, the ratings are given accordingly and the weights are given. So from the spatial data, you will get the classes, area of these various classes which are shown over here, that is required to multiply by your weight rating, and the weights are given to you. The weights are already there. So FVI is again, that is flood vulnerable index map. Same formula, I is equal to 1 to n Ri into Wi, where Rr into its weight, Cp into its weight, and PD into its weight, population density into weights. And the final map, as we have to overlap flood hazard index map over flood vulnerable index map, we have to make the same classes like high risk, high, medium, low, and very low. The final map of flood vulnerable index map, final map of flood hazard index map have same classes. Then only you can able to find out flood risk index map, that is FRI. So high risk, high, medium, low, and very low respectively. So this gives the flood vulnerability index map FVI, wherein you can find the various areas ranging from very high vulnerable to very low vulnerable. Again, superimposing this map on Google Map, you can identify the name of blocks and the area covered in square kilometer, which are at very high risk, moderate risk, low risk, and very low risk. So these are the blocks, taluka wise we have considered. So these are the blocks which are vulnerable. The class of vulnerable, in which class of vulnerability it lies. For example, Satna and Chalisgaon, so they lie into highly vulnerable class. How this we have find it out? That we have find it out using this FVI, and this FVI map where we superimpose on a Google map, wherein you can exactly able to know which village, which area is having high vulnerable class to that of very low vulnerability. After preparing these two, our basic aim is to prepare flood risk index map. So flood hazard map and vulnerability map were multiplied to generate the final flood risk map of the study area using the weighted sum method. The risk analysis were carried out taluka wise. The classification were done on 5 division scale: high risk, high, medium, low, and very low respectively, based on geometric interval method. So FRI is equal to flood risk index is equal to FHI, that is flood hazard index, and FVI, that is flood vulnerability index. So FRI is equal to FHI into FVI. So the high risk zone area indicate high population density, high rainfall, clayey soil, agriculture area, and flat topography, which includes regions from Chopra, Jalgaon, Bhadegaon, Chalisgaon on the nearby areas from Gir, Vagur, and that of the Tapi River. So this has been identified, this area has been identified from the flood risk index map. this particular map is useful for policymakers, useful for decision makers, that which are the areas they are at high flood risk. List of villages which come under very high to high risk zone due to releases from Hatnur Dam and high rainfall in the Tapi and Bagur River Reach. That has been prepared, and details with village name, taluka, population affected, that has been worked out for the entire study area. See, these are 34 number of villages with different population which are at high risk. So list of villages comes under very high to high flood risk zone due to release from Dahigaon Weir and rainfall in the downstream side of Gir catchment. That has been prepared. So these are the villages which are downstream of Dahigaon Weir in the Gir catchment. That has been listed out in this particular table. How to validate this? The study which we have carried out, and we have identified the various areas, and we said that these specific area is at high risk or low risk or very low risk. So for validation purpose, the validation of prepared map is an essential step in the development and identification of flood prone areas. The validation of prepared flood risk map is done with the map prepared by Tapi Irrigation Division, State Government of Maharashtra. The flood prone area in this map is marked by red line on both the bank of Tapi and Girna River. So this is the map which we have collected from the Maharashtra State Government Department, and these red lines, these are the areas which they have marked as high risk. These areas which are between these two lines, they are identified by them as the high risk areas for floods. So after careful observation and comparison, we can say that the area or region which marked as waterlogged or inundated for the proposed dam, Nimna Tapi near Padalse village, same area is categorized under very high and high risk class in third risk map developed using AHP MCDM technique. Based on our analysis, we come across that this is the region where the tributary of Gir joins Tapi River. This is Tapi River, and somewhere here is the Hatnur Dam. I think here or here. This is the Girna, yeah, Hatnur here. So to tap the water potential of this entire basin, as outcome of our analysis also suggests that even if there are no releases from Hatnur Dam, if there is heavy rainfall in the Girna basin, may lead to floods into Tapi River. In other words, and therefore, the government has proposed to construct a dam downstream of that of Hatnur Dam, where Girna River meets Tapi, that is called Nimna Tapi, and the dam name of the proposed dam is Padalse Dam. And this Padalse Dam is now under construction. So such analyses are useful not only to identify areas which are at a high risk of flood, but at the same time, the water potential of the basin may be tapped here, as we know that there is no dam in Middle Tapi Basin. The Hatnur Dam is just at the outlet of Upper Tapi Basin, while Ukai Dam is just at the outlet of Middle Tapi Basin. In between the Hatnur Dam and Ukai Dam, there may be small weirs to check the water for the purpose of irrigation and storages. But there was no major dam. And as outcome of our analysis, we have derived that there is a lot of water potential from this Girna basin which may be trapped, which actually now by construction of dam at Nimna Tapi, that is the place called Nim Tapi, Padalse, location Padalse, a dam has been proposed by government of Maharashtra to be constructed to tap the water potential of this entire Girna basins. So when we started this study, when we carried out, this is the work of one of my research scholar. As you have seen, the DEM used of 2010, and she has started her work somewhere in 2011 and 12, and therefore the DEM used of 2010 year. So when we have started this work, that time we were not knowing that the government is also planning to construct a dam near Padalse and very close to that of the Hatnur Dam to tap the water potential of the Girna Basin. So, why I am saying this? As we wanted to validate our results that this month amount of water may be generated and these areas may be flooded. Number one, we got the map from the department, irrigation department of Maharashtra, who have marked the areas which are at flood risk. And the areas which we have computed, they are almost matching with each other. So in this research, flood risk zones map is created using AHP MCDM approach based on expert opinion and GIS based methodology for part of Middle Tapi River Basin in Maharashtra. Total 9 parameters were considered in the present study based upon its topography, annual average rainfall, and vulnerability to flood. The multi-criteria analysis along with AHP was found to be useful for flood risk analysis due to its capabilities to handle large area data sets of data scarce region. The FHI was computed by integrating 6 parameters, that is slope, distance from main river channel, LULC, soil, drainage density, and rainfall, while FVI were formed after overlaying row river intersection point density, crop production, and population density. Rainfall, drainage density, distance from main river network are the dominant parameter concerning hazard, and crop production concerning vulnerability, which are responsible for the flood damage in the study area. The resulting FRI, that is flood risk index map, indicate that 527 square kilometer area are under very high risk zone and 2,804 square kilometer are under high risk zone, out of which most of the area from Jalgaon district respectively. In view of obtained results, Chopra Taluka from Jalgaon districts are highly exposed to the risk of flooding. The identified areas as high risk require more attention and in-detail analysis of floodplain considering its cross sections. AHP in combination with GIS framework can be used as alternative method while making flood inundation or flood-prone zoning map in ungauged basin. The proposed methodology can be useful tool for the flood disaster mitigation measures. Further, more improvement can be achieved by refining AHP approach for weights after discussing with experienced expert involved in flood analysis. So this was the presentation on the Girna Basin, how the flood risk index map has been developed using the spatial data sets. So I would like to see the questions, if any questions are there. Hello.
I think there are multiple questions in the chat.
Yeah, sir.
I can read them if you want.
Sir, I'm not able to see it. If you can read, that will be fine.
Okay, so the first question was, on the basis of the procedure and technical aspects, how can we distinguish between flood risk and flood vulnerability?
On the basis of
procedure and technical aspects of your study, how can we distinguish between flood risk and flood vulnerability?
Yeah. So actually, flood vulnerability for flood vulnerable areas may have a population or may not have a population. So basically, vulnerability with respect to the people who are residing and who are affected because of the recurrent flooding. So that way we can distinguish between the flood risk and flood vulnerability.
So just to add for that,
yes, sir.
whenever you are saying risk is a combination of 2 or 3 factors. One is the likelihood of an event and the consequence. So if an area can be vulnerable to floods, but it may have low risk because, as Professor Yadav pointed out, there may not be enough buildings or enough damage that can be sustained, or there can be less number of people in that area. So the risk can be low, but vulnerability can be high. Maybe you will have floods in that area, but nobody is affected. So in that case, the risk will be
flood vulnerable. Yes, sir. Yes, sir. Exactly.
Okay. The next question comes from Chiranjit Singha. He says, or he or she, does there have any multi-collinearity among the causative factors where model uncertainty like validation accuracy is huge?
Exactly. What does the Singha mean by multi-collinearity? Because when we are using AHP, we are comparing all the factors with each other. So question of multi-collinearity, that may not exist here, because the experts compare all the parameters with other parameters and weight it. If you are saying that the influence of one parameter on another parameter, so it purely depends upon the weights which are given by the expert for various factors. And as we know that the expert's opinion may change for few factors which are very closely related to each other. And in that case, if you are changing a weight slightly, the results will definitely change. So what you are talking about, uncertainty like validation of accuracy issues, so that can be said as a limitation of method of AHP. So in case of AHP, if you are changing the weights, definitely your results will be different for different weights. To avoid that, therefore, to avoid that, though we have surveyed 60 forms, out of that 20 forms we have rejected. Why? Because we checked the consistency ratio of each and every individual expert, and we checked that the ratio, consistency ratio, should be less than that of the 10%. Yes, sir.
Okay, so that's very good. The next question is from Raju. He says, weights and ratings, are they standard values for all basins? Are they different?
No. They are different for different basins. So for each basin, the factors may be different from each other.
Okay. The other question was, can we create dynamic real-time flood risk map using AHP or any other method? Dynamic flood risk map.
Yeah, I got the point. But when we are taking the weights, and that weights are given by the experts, if your AHP model is ready and if you are only inputting the parameters, then only the dynamism is possible. So, which may not be the case here.
This is for the long-term vulnerability as well as the risk.
Yes. So as pointed out, that this map can be useful to policymakers. This map can be useful to decision maker, that if they wanted to give some relief measures or they wanted to go for mitigation measure. For example, as we have seen here, that particular area is at high risk, and there, if it is possible to construct a levee which protects the entire group of 10 villages. So to take such a decision, this will be helpful.
Okay. If there is one question by Jagdish Vishay, he wants to probably ask the question about rating of road intersection point density. That's what. He has a doubt, but he didn't express what is the question.
No, I think he is saying that the cross intersection with the road and river, right? So here, when we say the rating of road intersection with the river, how far is the point from that particular intersection? Based on that, or the number of points considered for one particular area, because we have divided into taluka, and in that talukas we have considered the number of points or number of roads which are coming across the river, and based on that this classification is carried out. I think the Jagdish, now you understood that how we have done the analysis for road intersection point density. It is not like that exactly at the point of road river intersection definitely the flooding will happen. Here point here is the taluka, and in that taluka how many number of points are there which are what we can say intersecting with the river and road, and definitely these number of points will vary from what we can say a subdivision to subdivision. That what I am calling as taluka, right? So from taluka to taluka.
Hello, sir.
Check this. Yeah.
Means if the number of intersections are more or the point density is more, then that area will be the more vulnerable,
prone to flooding. Yeah.
Okay. And my another doubt was that as you said, we have given the weightages to the taluka wise.
Yes.
So the maps we prepared using ArcGIS.
No. Weights are not given taluka wise. The area is divided taluka wise. Weights are direct comparison between two parameters.
But so the maps created are like isopleth maps, means
Which map you are talking about? Whether it is for FHI or FVI? Because
both.
maps prepared for FHI are different and FVI are also different.
So for both the cases, map is prepared on the basis of ratings and weightages, right?
Yeah. So
but
suppose slope is there. Let's take a slope. So according to slope, we have classified into five category, and the entire study region will be divided into 5 parts. That way, not the taluka wise. Taluka wise, I have talked about vulnerability, not about the flood hazard index mapping.
Then, sir, how
that will be based upon the sub classification of that parameter. Suppose slope is there, the slope is divided into 5 parts. So entire basin will be divided into 5 parts, like that.
But sir,
for example, population. So population we are divided into 5 class. So entire basin will be divided accordingly.
No, sir. After from the derivation of the summation formula for FVI or FHI, we will get the FVI value, and depending upon that, we have prepared map, right? Or we have given weightages as per the taluka.
No, weightage will remain same for the parameter. Okay. While the places vary, depending upon that, you will work out the FHI or FVI or FRI. See, this will be more clear when I will take one example on day 5. So I have prepared one example on this, wherein you will be doing the hands-on practice session, in which you will get exactly the idea how this FRI is required to be calculated.
Okay. Thank you, sir.
So, yes, please go ahead if you have a question.
Yeah, so regarding land use land cover map, you have said you had obtained from USGS website. How far accuracy land use land cover? Because USGS website means it is 30-meter resolution, and whether any curve number you generated based upon the land use land cover soil map. And now you said you used 10.2. Now it's not working 10.2. It's 10.41 only working. Whether any hectic GeoHMS process.
Surendra, you are not audible. Better you type your question.
Oh, okay, sir.
Yeah, please. I know it is a very good question. Please type your question if you can, so that Yadav can answer.
Sir, if you have followed, please reply.
Yeah, but I think he's asking about the resolution of the land use land cover map you got. So
yes,
how accurate it is with respect to the ground reality. That is one question, I think, if I got the question right.
Yes, sir.
Yeah.
Oh,
so that's the first question.
So not only for this analysis, for all the analysis, whenever we are downloading the DEM, the resolution of DEM is is of most significant. In our analysis, we have used 12.5 meter resolution DEM with horizontal accuracy. I have not talked about the vertical accuracy. So all DMs have different horizontal and vertical accuracy. Depending upon that horizontal and vertical accuracy, the accuracy of your work will accuracy of work will also depend. But when you are validating it, like as I am saying that the irrigation department has identified certain area where the depth of flow during 2006 flood was this much, and that depth, when I am trying to compare with my simulated depth, then the question of accuracy of DEM, right? So I think that can be answered in this particular way. Otherwise, if you are saying that coarser the DM, if I am using a DM of 60 meter resolution and vertical accuracy of 10 meter, and then I am trying to do the flood analysis or flood studies, definitely you are right that way about asking about the accuracy of your model. But when your accuracy of model, you are georeferencing or you are comparing it with the observed depth, then your simulated depth and observed depth, if they are matching fairly well, probably your model is performing better.
So
yes,
just to add one. Go ahead,
Sir, did you
Surendra.
generate any curve number map, land use land cover map? No, sir. Did you generate any curve number maps, sir?
Did you generate
Pardon
any
me?
curve number? Did you generate any curve number map based on the land use, land cover?
See, that means, Rajan, you have not paid proper attention while I was presenting my work. The basic aim of AHP approach, as I have mentioned in the conclusion also, that wherever it is not possible, right, to go with the rainfall runoff model because of lack of data, right, observed data, right, there
Yes.
this particular approach can be used as an alternative approach to it.
So let
Okay,
me, summarize. I think what Professor Yadav indicated in his presentation is that um, you have certain amount of data, whatever data you have. Can we generate uh, risk maps, vulnerability maps, so that that can be the first part of the decision making for emergency management and so on, so that they can identify potential areas where there is high vulnerability and high risk. So this is the initial part of the decision making for emergency planning or emergency management. Now, my question, based on your work, it's a wonderful work where you can identify. I'm assuming that if you remove the AHP process, which is the process of getting the rankings and weights associated with the different causative factors, if you assign some weights, which are reasonable weights, this kind of map can be generated for entire India, I'm thinking. Is that possible? That's the first question. Fast, very fast. You can generate for the entire India. Is that possible?
But the only thing is that when the conflicting parameters come, then how to decide it? If person is very experienced, he can develop the map. Definitely, he can develop the map without using AHP. But if the person is a technical one and I maybe not having that depth of the knowledge, probably he may get confused that which slope I have to consider at higher
Okay.
risk, or what distance I have to consider from the river, which will have a more of effect of flood, etc.
So the AHP has very real value there because it codifies the local knowledge, what is there about the landscape and the vulnerabilities and other issues, which comes from different experts. So the idea of AHP aggregating all this expert knowledge and domain into a small set of rankings, that is really beneficial because you are capturing the knowledge which is available from these experts. So the other question is what are the two main uncertain items or two uncertain factors in your process which might completely change the vulnerability from one category to another category? So for example, from high risk to high risk to risk, sorry, very high risk or then high risk. So what I'm saying is, if there is uncertainty in one particular parameter, if you change a little bit, then it goes into completely different category. Is that possible if there's uncertainty in one of those factors?
Yes, sir. Yes, sir. It is possible, and one of such factor is rainfall,
Yeah, so
because
definitely
the
rainfall. Yeah.
weight of rainfall is highest. So if you change little bit the weight of rainfall, the entire thing will change.
Okay, so that is definitely the other thing is that in United States we have the flood rate insurance maps, like we call it as flood insurance rate maps, that is FIRM. Okay, so that means the agencies will develop the flooding risk, one in a 500-year risk, one in a 100-year risk, one in a 2-year risk maps, and then they make it available to the insurance agencies as well as the public, so that the insurance agencies, every house in the United States is insured, unless you don't want to insure your house, or if you own the house and you are not owing any money to the bank in the form of a mortgage, you don't have to you can decide not to insure your house, but in general, you have to insure your house. So does the insurance exist for houses in India based on the flooding?
Yeah. So this is a very good point, which has been explained by Dr. Ramesh. In our country, all the participants, please listen this very carefully. This study which we have carried out, as such, it's useful to policymakers. But in our country, nobody is taking the flood risk insurance except where it is a compulsion by the loan agency. Suppose if you are taking loan against your house and the agency who is giving you the loan or sanctioning you the loan asks to go for flood insurance, then people buy the flood insurance. While in case of US or in case of Australia, the flood insurance purchased by the people. And at the same time, I have seen on the date or in the news that before the flood receipt, the flood insurance agent reaches to those areas and pay the insured amount to the affected people, which is completely absent in case of India.
So I think the vulnerability maps and risk maps you are developing can be used by a private agency to come up with insurance schemes. They can say that if you are living in a flood zone, we will insure your house. You have to pay a certain amount of money for every month or something like that. So that is possible. Okay. So the other question I have is that we are also interested in mapping the resiliency. So that means if an area is subjected to flood, how soon it can come back to normal position, maybe 3 days, 10 days, 15 days, based on the resources they have. So the next study, probably, I'm just trying to give a research direction, would be to look at the resiliency of different areas. So for example, an area affected in a highly urban area may come back to its foot very fast. It will recover very fast. But somebody in a rural area may not recover very fast. So the resiliency is also very important these days for us. We are looking at resiliency maps also.
Yes, sir, you are right. The city of Surat has got the most resilient city award recently. Okay. And as city of Surat is suffering from recurrent floods, this is the only city probably in the India which functions immediately after any magnitude of flood. The people are so resilient that the last 2006 flood, there were 2,000 crore rupees of damages in the city of Surat. But if you have visited the city of Surat after 15 days, the city was functioning normally. So as you have rightly pointed out, this is the another study which can be extended for the same area for which this flood risk map has been developed.
Okay. So that's very interesting in the sense to have the resiliency maps is also very useful for planners to divert the resources. If a city is takes more time for resiliency to come back to its original normal conditions, then you might send more resources to that particular area. It is a possibility, right? So there was another question by Tushar. He was asking, what is the risk of flooding from individual tributary flows as compared to basin outlet flows?
As such, no, I have not worked out from that point of view that what will be what we can say risk of flooding from tributary to that of basin outlet. I think if Tushar is asking, as the Girna River or Gir River is a tributary of Tapi River, so if we talk of flooding of Gir River, that will be the regions around the Gir River will get affected. Yeah. At the same time, the volume of water which has been discharged into the main river, it depends again upon the outlet where it is discharging. if it is discharging into the river, then there are again number of cases, whether the river in which confluences with the river which is discharging high flow is running dry or it is also full. So depending upon that, the flood conditions or flood scenarios can be evaluated.
Yeah, so that's a wonderful answer. Yeah, so basically, if you remember the risk definition, risk always has this attachment of consequence. So an event can happen on a tributary, an event can happen on a main river, but then the risk is always a multiplication of the likelihood of that event to the consequence. So if a river passes through a community where there is nothing there, no buildings, not many people, then the risk is very low. But if a tributary, even though if it is a small tributary, but it is heavily populated and it has a lot of assets nearby, then the risk will be much higher for that particular location than the main river because of the consequence. So consequence always builds into your risk. That is important.
Yes, sir. The Mithi River of Mumbai. So if you have participants may be knowing this fact very well, that the Mithi River, that is a small tributary passing through the suburb of the Mumbai, but whenever it gets flooded, major part of the Mumbai get flooded. So as it's not necessary that only the main river, but a small tributary may affect the large population settled around it.
Yeah, so that's what defines the risk very nicely, especially even when I was talking about dams also. The dam may have a very high likelihood of a failure where a dam break can happen and then you can have a flood. But if that is not affecting any population downstream, then the risk is low. So in that case, so if you remember, I showed the risk matrix yesterday with the likelihood of the events versus the consequence. So that is important. Yeah. So any other questions for Professor Yadav?
Sir, yes, what you have said. Yes, you are audible.
Abdullah is asking a question.
Yeah, my question is directed to Dr. Ramesh, but rather it's a suggestion I'd like to seek from Dr. Ramesh. So you talked about flood resilience. I am already working in a particular area on flood risk and flood hazard mapping. In case I would like to add it to my area, what inputs would be required in case I go for this particular research direction, talking about data requirements and other process.
Okay. So flood resilience is basically how fast a community recovers from a catastrophic event. So it can be quantified based on the number of days. So all you need to do is go to your historical database and see, for example, there was a electrical power outage. So it took 5 days to restore the power. So, that kind of factors, or how much time does it take to clean up area? How much time does it clean up to take care of some of the vulnerable facilities like hospitals or schools? So how fast a system comes back to its more or less 90% of the normal conditions or 50% of the normal conditions. So if you can get some data, then you can start mapping the resiliency of those basins or resiliency of those areas. And that really gives us a snapshot of, if some areas are very resilient, then the emergency management professionals don't have to worry about those areas. But those areas which take more time for recovering to at least 50% normal state, then you have to invest more resources there. For example, if there's an electricity outage because of heavy thunderstorms and heavy rainfall and flooding issues, then you need to send more people to those low resiliency areas so that they can recover to some reasonable extent faster. So you can map the map the resiliency. You can also look into the internet what we call the community rating system, CRS. So that means what they do is in US, every community has a rating system. So that they define based on the resources they have. They're based on this, what kind of activities they take after the flood, how many vehicles they have, how many divisions have some kind of emergency evacuation, or how many areas have some kind of a shelter so that people can move in and then come back again into their houses. So it's all the rating given to this is a little bit arbitrary, but at the end of the day, you can come up with some kind of resiliency map that might be really beneficial for
exactly.
emergency management professionals.
Thank you, sir. Thank you so much.
You're welcome. Yes. So I think the whole case study and the idea of mapping both vulnerability and risk, that's a wonderful but there will be definitely a mismatch between risk and vulnerability, right? When you overlap on both of them, sometimes there is high risk but less vulnerable, but the other way around. So sometimes that will happen. If you were to improve one part of your methodology, which one would be that?
Sir, I will say that there should be some other method can be used where the weights, it should be independent of the weights. But as you have said, that for policy makers, right, as a guide, if you wanted to use it, then the approach which I have presented probably is one of the solution for it.
Even when you are generating this flood risk maps as well as the vulnerability maps, is it possible to keep the rankings provided by the experts constant, but you vary to do some kind of sensitivity analysis so that you get three maps basically? The one map is lower end map, the other one is the middle end, the other one is high end. So that means you are basically telling the decision makers, depending upon the uncertainty of my inputs, for example, rainfall or the errors within the DEM, but the other ones are more well classified. For example, the drainage density, intersections, and land use maps are typically very accurate. DEM is the problem and the rainfall is the problem. So if you were to just play with those numbers a little bit and generate slightly different maps, so that gives the decision makers to see the uncertainty band in your map itself. So for example, you have a area which you marked as highly vulnerable or high risk area, but when you do a sensitivity analysis, you can say that it can vary from this area to this area, a little bigger area. So that way, I think it will give you a little bit of uncertainty assessment of your whole approach, and it gives you little more guidance to the potential problem solvers. For example, the emergency personnel can think, okay, my risk area will be somewhere 10 square kilometers area to 17.5 square kilometers area. So I know that with all the uncertainties associated with my things, I can basically say that I have to manage anywhere from 15 square kilometers to 17 square kilometers. So that kind of uncertainty band, if we give, I think probably that will really help the decision makers. So that can be an extension of your study.
Yes, sir. Yes, sir. And basically what happens in case of developing countries, we are having a less funds. And that time it becomes very difficult that where to allocate that fund for taking the flood mitigation measures. So what you have pointed out is rightly useful to the decision makers. If they know that this is the range, then exactly to the which villages or which areas the funds is required to be diverted first, or they can decide about the priority of it.
Yes, I think that's, yes, you're right. So any other questions to me or Professor Yadav before we finish this third day session.
Sir, I have a question.
Mm-hmm.
We have communicated one paper to very reputed journal, and in which we have used certain MCDM techniques, and we have derived certain results out of it. Now the reviewer is asking that the results are okay, but will you please tell us about the methods, that why you have used X method of decision making, or Y method of decision making, or Z method of decision making? So what could be the answer for this, sir?
So the reviewer is questioning the rationale behind a use of a method or a use of a multi-criteria decision-making method. Which one?
Yeah, we have used 3 different methods. So he's asking why you have used this method, and this method.
Okay.
Yeah.
I think you can politely answer, saying that the 3 methods, first of all, you form a small matrix in your mind or on a paper to find out what are the advantages and limitations of each method. And what is the main element that method is considering. So now you tell the viewer saying that the 3 methods may arrive at the same conclusion or may not arrive at the same conclusion, but each of them have their own advantages and disadvantages, and each method will consider a different type of element to make that final result or conclusion or whatever. So you justify saying that each method has its own advantages, and that's one of the reasons you are using the 3 methods. And each method can be region specific, data specific, parameter specific. So you can say that the users of this methodology or the approach have this choice to pick up one of them which suits their data requirements. You can argue in that way, or at least justify your point of view. That is my opinion.
Yes, sir.
Yeah. So, I mean, sometimes the reviewers ask questions because they want to ask questions. They may not have a real curiosity to know the reason why you are doing it, because they want to fill up the paper with some question. So ideally what we have to do is accept the question, be polite, and say that the rationale behind why we are doing this. That's it. So that will automatically satisfy, I don't want to say the word ego, but sometimes it will satisfy the ego of the reviewer. Okay, that is good. So any other questions or anything else? Okay, looks like we have reached, I don't know what is the time in India right now.
It's 8:15 p.m., sir.
Okay, we were talking about risk and vulnerability and all other issues. We have hurricanes, what you call typhoon, cyclones, I think. Yeah, cyclones. And different parts of the world calls them different names. For example, in Asia Pacific, they call it as typhoons and so on. So because all our houses are insured, especially the rooftops, because our rooftops are made with tiles, so everybody prays that their house is hit by the cyclone or hurricane because they will get a new roof. You see? So let's say you have a roof for the last 15 years, you pray for the winds to attack your house so that you can get a new roof. It's so funny because they want to use the insurance money to get a new roof. Anyway, so that's the thing. And usually during the hurricane times, whenever there's a power outage, people also pray for power outage because they get free generators from the government. So, so that's another incentive of praying that a bad thing happened to your house or power so that you can get some generator for free, which is not that expensive, by the way. It's only $400 or something, but still people want free stuff. right? So that's what.
Same as India, sir.
Sir, but
It's everywhere. It's everywhere
sir,
like that. Free stuff
Yeah,
is always
Krishna ma'am.
good.
Krishna ma'am, please.
in Tamil Nadu and all, when the flood is happening, only 5,000 is the sir. What to say? The amount given to the people who are
Oh, the
affected.
compensation.
Compensation.
The compensation.
Compensation. And during
Okay.
the thatched roof only, they are in Kadalur district and all, it is often frequently faced by the flood. The roof will be gone during the flood and cyclones and all. Only 2,000 or 3,000 is the
Okay.
compensation.
Okay.
Yes, sir. No flood
We
insurance like.
we have a requirement that they have to replace the entire roof
Yes, sir.
in a new form. So because
Yes, sir.
we are paying a lot of insurance. I'm thinking that because now you have a lot of health insurance schemes in India, maybe flood insurance will be coming very soon,
Okay, sir.
right? Is there a possibility?
Hope
I don't know.
hope
Maybe.
for
I do not know, sir.
Hope for
And
it.
for crops also, when we are visiting the crop, it will be under flood inundation, but it will not give the good yield, sir. But only the crop die only they will give the insurance. That is
Oh,
the
okay.
farmers are facing the trouble, sir.
I'm in touch with one of the students I worked a long time back, and he is working in a satellite company. Now they are trying to educate or at least help farmers to find out what is the soil moisture in the next 15 days, what might be the forecast and everything, what type of crops to grow. So I think the technology is improving slowly. The insurance agency will also start thinking about, okay, we can insure the farmers and we can take the risk. I don't know if you have renters insurance. We also have home renters insurance also in our country. So I don't know if you have that or not. Let's say if burglary happens or somebody robs your house.
Yeah.
Okay, sir.
I don't know. Do you have that or no?
Yes. We have, sir. We have, and people do take it, but very less number. Maybe 10%, 15%.
Okay. So one final question, sir. Have you approached this vulnerability and risk maps to any government agency and showed your results, and what is their opinion? What is their feedback?
Really, sir, we have communicated our result to the engineers of this specific area, and they really appreciated it. That the results of our study are really useful to them.
Yeah, I think I like that. I mean, the study really helps to, I would say, if Indian government has resources, they should map the whole country with this kind of mapping so that people will know exactly where they are living and what is the risk associated with that and so on. I mean, I think this is a wonderful study.
This map can be how it can be validated, sir, in the field.
We have to go with the historical data of the past floods to
Sir.
see if the highly vulnerable areas identified by this approach are pretty close to the what the maps are showing, and it is easy to overlap because in the past historical events you could have had the boundaries of floods that are affected. So all you have to do is overlap, and it doesn't have to be a perfect match. As long as the majority of it is matches, that means the method is validated and it can be easily applied. Right, sir? Did I say the right thing?
Sir, what you said for India also, so many things are happening, but all these things are in isolation. Actually, somewhere some coordination or integration is required, and if that is done, probably it will be taken care of as India as a whole.
About the validation I talked about, did I say it correctly? That's what.
Yes, sir. Based on the probability of occurrence.
Ma'am?
Based on the, as Professor told, based on the probability of occurrences, it can be validated.
Okay. Sir, Dr. Ramesh. Hello.
what I'm saying is the answer I gave, is that correct for validation process based on historical floods? That's what I meant.
Yeah, sir. She is saying yes. And just I wanted to introduce Krishnaveni ma'am to you. Dr. Ramesh.
Sure, please.
She is director. Please, ma'am, please introduce.
Sir, I am Dr. Krishnaveni, basically professor in Water Resources, Center for Water Resources in Anna University. I used to teach the surface water hydrology, advanced hydrologic analysis design, and flood modeling and drought assessment, sir. Really, your lectures and professor lectures were very useful in enhancing my knowledge, sir. So definitely,
you tell that, you tell that you are working as a director. I don't know the name of institution. Which
it's an Institute for Ocean Management, and we have started working on the impact of coastal, that is the climate change on sea level rise. So today's lecture, I have seen you have presented some important aspect on the sea level rise and in different world how it is occurring, what is the risk of various places. So we are started in working with the climate, that is sea level rise with the context of climate change.
Okay.
Yes.
Do you have I talked about nuisance flooding. Do you have nuisance flooding, water coming in when there is a high tide?
Yes, sir. In some of the sea level rises in so many places, it has been felt, sir. In Kollidam and so many places in Tamil Nadu, and this sea level rise is being felt, and we have to yet to work on that, sir. And as you asked, the flood hazard vulnerability, similar to Professor Yadav, sir, we have worked for the government institution or disaster management cell. Flood hazard vulnerability, we have done the mappings. And one student also worked, the PhD student, he got his degree also, PhD degree. He was awarded.
Yeah, I think that is required for the coastal areas for India, especially the saltwater intrusion issues, and then the nuisance flood issues and other issues. We are coping with that. Unfortunately, our governor, we call it as governor for the state, like your chief minister, we have governors for the state. The governor is from a Republican party. He does not believe in climate change and sea level rise and all those things. So the state is not giving a lot of money to improve the protection for the coastal areas. So what the local, we call it as communities or municipalities, they are taking the lead in trying to address the sea level rise, because it is a big problem. So maybe in 50 years, we will see a lot of area inundated with water, and we might lose some water for that. And the saltwater intrusion is a big issue, because even though we have a lot of rain and lakes, we still rely on aquifers for groundwater, for water. So we extract water every day.
Because
we have tremendous
most of the industries also located in the coastal areas, sir. And in many places in Chennai, the seawater intrusion already happened, even up to 15 kilometers like that, sir. So that is
scary situation. That is very scary situation. 15 kilometers is a lot inside. So I think this vulnerability mapping and risk mapping, I think that has to be going on for the whole India. This is a wonderful study. I really enjoyed all the factors meticulously you have included in your study, because not all studies will include all these factors. They will include only maybe 10 or like that. But and then gathering of so many people to do the AHP survey, that is also amazing. So it's a great work, and I think it needs to be replicated for other states and everywhere, so that we can have a overall risk map for India.
Sir, one more thing also I want to clarify. Here, every time they will do the crisis management only. How about in US, sir? They are doing risk management, or what's the approach?
They do everything, because they have tools for, as I said, the community community rating system, CRS, and they plan very well for an impending disaster. They do that, And of course, there are so many private companies which will insure your properties. So government has less burden on getting you back to normal, because you can always claim the insurance claim from the particular private agency. So that is helping people to adjust that. But I think more than that, the forecast systems are amazing. So we will talk about that, the warning systems and forecast systems on day 5. The forecast system, even Bangladesh has a very good flood forecasting system, which is documented in international papers. So we need to have a very strong forecasting centers within India, so that they can forecast, for example, all those Chennai floods and Mumbai floods. They could have avoided loss of life and other issues if there were enough forecasting systems which can give a lead time of 10 days or 5 days. Let's say if a moisture system is coming, then we call it as atmospheric rivers, or even hurricane-based forecasting. If you have that system, then at least you can protect vulnerable population. People who are old, people who are not able to move from their houses, people who cannot, don't have jobs, who are having medical issues. We can protect them, and that's what is the main point of the U.S. government, is to protect all those people who cannot evacuate in a situation like a big flood or big hurricane system. What they do is they target the vulnerable population first and help them for that. So it's very, and I think that is what I think India should head to have that flood forecasting system, and improved precipitation forecast also. If they have that, we can do better job in protecting the vulnerable population.
And the connectivity is missing, sir. Weather forecasting and real-time modeling, no, sir. Hydrologic simulation model. That there is a gap in that.
You are right. And then the other problem is also that most of the cities are dealing with heavy urbanization. That means the impervious areas are going up like anything in India. So with that increase, you need to have more efficient stormwater management system. You need to take the water very quickly from the roads and put it somewhere else. So that means if there is an impending huge rainfall event coming in the next 5 days, a survey team has to go and start cleaning up the storm sewers. If there are any obstructions, the plastic bags, this is the main problem in India, the plastic bags going into the storm sewer system. Yes. So if they can do that, the drainage will improve. That is what is important. Now, you might think, okay, developed countries have very good stormwater management system. No stormwater management system can handle a huge amount of rain in short duration. So even Japan, for example, if they have good amount of 200 millimeters of rain in 15 minutes, they cannot handle. They have to stop all the trains because the water cannot drain fast. So therefore, in India, the stormwater network, stormwater management network has to be improved, and also there should be some kind of maintenance plan and also emergency maintenance plan. If you are expecting a flood in next 5 days or so, we should send a crew and then start. And we do that for our hurricane preparedness, for cyclone preparedness. 5 days before the forecast, we get the forecast that hurricane is coming your way, possibly, and we start preparing. Everybody prepares. The government also prepares, fortifying the power lines. They'll come and make sure that everything is working, the shelters are working. So I think proactive planning will really help.
That is missing, sir, in India. It is missing. Another one, sir, one more thing. Floodwater harvesting is a challenge in the context of climate change. The now more frequent, high intense intensity rainfall is occurring now. So apart from rainwater, floodwater harvesting, now it is needed, sir.
That is definitely, you are right. Yes, that is right. Yeah. So we need to, near the urban areas, you are experiencing high intense rainfalls. It can be because of heat island effect or some other effect. So if you see rural areas, they are experiencing some rain, but cities are experiencing tremendous amount of high intense rainfall. So some of the cities in the United States, what they have done is they have constructed these green areas where they can capture the water. Whenever it rains, they can capture. These are called green basins.
Green basins.
Yeah. So they create them within the city, multiple areas, and then they collect all the water and drain it to a bigger reservoir somewhere else. That's what they do. So I think
Yes.
not all cities have it. For example, Pittsburgh has it, and some good cities, they are doing this because there's a heavy urbanization. Whenever there's a too much amount of rain, they need to start thinking about, as you said, flood water harvesting. I mean, that is very important as opposed to singular harvesting. And then they take the water immediately and do that. And then the green design, especially within the cities, to reduce the impact of urbanization, they are on purpose allocating some areas which can absorb the rain. That is also there.
Yes.
Okay.
Thank you, sir.
Sir, we need to stop here.
Yeah.
That's a good discussion, and definitely all the participants have enjoyed it. Only thing what I can say is that, Dr. Ramesh, we never want to leave you. We want that we should continue to listen you, whatever may be the topic, and the answers are always wonderful, and we really enjoyed the way in which you explains the thing. Thank you so much. Thank you, ma'am.
Thank you so much.
Thank you so much for your input.
I mean,
Rashmi,
yeah,
you want
we
to
will
take
meet.
photo?
Yes, sir. Yes, sir. I request everyone to switch on their cameras, please.
See, participants, you have got chance to take pick with Dr. Ramesh and Dr. Krishnaveni, ma'am. So she is director in Ocean Institute, Anna University. Anna University, no, ma'am?
Yes, sir. Yes, sir.
Next
Actually,
time
in
I will come
the
in. Next time I'll come and meet you when I'm in South India.
So
Yes,
that's
Thank
wonderful,
you,
sir.
You're welcome, sir.
Yeah.
But sir, we wanted to have you at SVNIT. We missed that opportunity. Due to
I will
COVID.
definitely come.
Yeah,
I will
yeah.
definitely come.
Okay, sir. I have taken. Thank you. Thank you, everyone.
Thank you.
Thank you, sir. Thank
So
you,
we'll meet
everyone.
tomorrow.
And good night. Good
Yeah.
night. Bye bye. See you.
Good night, sir.
Bye bye.